Do you have any concerns about the capabilities of AI?
I don't think AI is the danger. I think they are the danger. They just have way too much power. The secrecy, the policy choices they're making are just bad for society. There is a drive to survive, which would create a very different kind of intelligence. We get like amazing new powers and we can choose what to do with them. Just don't put it in control of the nukes. Problem solved. We need to figure out new ways of establishing what's true, essentially. There's no simple answer. They are the problem. AI is not the problem. They are the problem. And is the worst of them.
Can you explain how long you've been involved in artificial intelligence and how did we get to the point where we are now where artificial intelligence is being used by the masses?
Boom. Yeah. This is so I've been in this since I started thinking about it. Jesus, this is a very hard question. I've been like technically working with artificial intelligence to start my PhD in 2004 in sunny Essex in England. Not sunny. But I was studying it before and so on, so I've been thinking about it for a long time.
The nature of AI in 2004 must be very rudimentary compared to now.
Yeah, that's an interesting point. It is largely wrong. Basically, yeah, so when I started with this, I got into this because I wanted to understand the mind. I wanted to figure out, how does the brain work? Where does consciousness come from? Where does this, go, and so on. And so I started philosophy and stuff like this, and then I realized I needed to build it. And building it is where things get interesting, because when I took my first AI course in 2001, I think, a lot of the theory behind what is now called deep learning and a lot of the prototypes and so on were already there. I mean, basically, deep learning is what we nowadays call neural networks, and which is, it sounds very fancy, it's in some way inspired by the brain, but basically it is multiplying numbers together. You basically put in a lot of numbers and you have this big system of, you can think of it as like basically interlinked equations, and then other numbers come out at the other end. And what's happening here at the core is that you're multiplying and multiplying and multiplying and multiplying. And the idea is that like the numbers that come in represent something, for example, the pixels in an image, or like the letters in a sentence or something like this. And the numbers that come out on the other end represents like the movement patterns of a robot arm, or like the notes in a piece of music, or the pixels in another image, etc.
Right.
So basically the core idea of like encoding things this way and then training the neural network. The neural network is basically a whole bunch of numbers which get multiplied with input in a different order, and to produce the output. And training them, that was already there. The algorithm for training them was already there.
Where did that come from?
Oh, it came from, because you see, the IDs aren't that hard. I mean, the core IDs are pretty simple. And the core IDs had been there in some sense since the 70s at least, probably even earlier, where people were looking at the brain, seeing that, oh, these neurons, you can see them as taking the input signals, and then basically they get activated, and then they produce an output, and the next neuron takes input from several different neurons, and you get activated and produce an output, and you can basically model this mathematically. The first successful model was called a perceptron. It was just of a single neuron, several of them in parallel. And basically what it did was sum the inputs, and you multiply the inputs, sum it up, and basically see if you get over, if the outcome is above 1. And then you output 1, otherwise you output -1. So it's like really, really very simple. It's like, it's not even high school math.
Right, it's like a binary, I guess. It is either above or below 1.
Yeah, it's super simple. And then basically the next conceptual jump was to think that you could put several of them after each other in sequence. And how would you actually train them in that case? You need to basically get the error signal that says basically how is the output right or wrong, and then you basically change the numbers in between so as to make it more, the next time you sort of push numbers through, make it more likely to be right. The back propagation algorithm, which does that, which again is kind of high school math, was first proposed in, I think, the 70s, Paul Werbus. But people didn't really trust it because you couldn't prove that it would work. You still can't prove that it would work. I mean, these things are like, deep learning basically doesn't lend itself to certainties. You're never really sure what's going to happen.
And when you say work in this context, do you mean that it would come up with a computational output, or that it would give you the output that you were hoping for?
Yeah, that would give you the correct output.
Gotcha.
You can basically, with deep learning, you can basically never prove correctness. And you had this, what was needed, several things were needed to basically enable this new AI revolution. The first thing was that you needed to change your mindset from the mindset of certainty and correctness to like, hey, funny numbers go in and funny numbers go out. Haha, let's see what happens, which is really what the deep learning revolution is built on. I mean, this sounds like I have something against deep learning. I don't, right? You know, it's like you just had to sort of basically get rid of this obsession with certainty, and then things started working. And then the next thing you needed was a lot of data to train on. So basically, typically data in the form of like, here's a description of something, and here's basically some label. Is this good or bad? Or thanks. Is this like so basically, here's like a text. Is this like, you know, news text or text from a short story or like a poem or something, and you can classify it. So, or like basically lots of images, and is this an image of a car or like an image of a human or something like this? So you needed lots of this data, which we didn't have for a long time. So, but then we had internet, and everybody had cameras, and everybody was writing text online and so on. So then we had lots of data to train on, and then we needed more compute power to actually train all these big networks. And for that, we needed graphics cards. So basically games, one of the many ways in which games have enabled modern AI was that people wanted games with better graphics. And companies such as NVIDIA and many others, Silicon Graphics originally, invented special hardware that could render better graphics. And because so many people wanted to play games, there's a lot of money was invested into producing better graphics hardware. And then like something like 10, 15 years ago, people started figuring out that actually you can use this graphics hardware to train the neural nets.
And how does a graphics card actually train a neural network?
Because you're kind of doing the same thing. You're doing a lot of very simple operations in parallel. In a graphics card, you're rendering a lot of pixels, and you're tracing a lot of rays, as it's called. Basically, you're ray tracing. You're trying to figure out how simulated light reflects off different objects. And this is something which isn't very interdependent. You can do it in parallel. And that's the same thing with neural networks. You do a lot of very simple operations, basically multiplications, in parallel. So with relatively little effort, you could just like see one thing as the other, and then suddenly we had the hardware we needed to train really big neural networks.
Interesting. And now, does the size of the neural network, does that account for scale or speed or both? Is it able to do more computations faster, or is it just one or the other?
It's able to do more computations slower.
Oh, really?
So basically, yeah. So modern neural networks are just very, very big, and we are very much constrained by the hardware when it comes to the size. So to take just yesterday, Meta, so Facebook, released a new set of new large language models, where the top one is about as good as ChatGPT, but it's completely open source. Anyone can download it and use it. You can even build commercial products on it. It's like free to use for everyone and free to modify and do whatever you want with, which is awesome. Wow. It's really good. But the big model here is 70 billion numbers. So 70 billion sort of real numbers, which is like some, I don't know exactly what precision they have, but if it's like 4-byte precision, that means it's something like 280 gigabytes, which is probably larger than the storage space you have in your laptop.
Right.
Maybe not. Maybe you can fit it on that one. I don't know. It's huge.
But it is big.
It's enormous. And it's definitely larger than anything you can fit in your RAM, in your main memory.
Right.
So you need a specialized hardware to run it fast. You probably could run it on that hardware, on your laptop there, but it would be very, very slow. And the problem is that every time you would need to generate one new character, you need to basically activate this enormous neural network and do at least 70 billion calculations.
In 70 billion calculations in what time frame?
Every time you want one new character, essentially.
Wow.
Yeah. So basically, we're capped to some extent by our hardware, and GPT-3, which then basically was developed into ChatGPT, is 175 billion connections, so 175 billion computations that need to be made.
Wow, 175 billion.
Yeah, yes, it's huge.
What would our brain be? Is there any way to map how many,
a lot of people get into this game, and it's kind of funny.
Is there an answer to that?
Yeah, the problem is there's many different answers depending on what level you want to model it on. So I don't actually know right away how many neurons we have in the brain. Is it like 1 trillion or something like this? Or maybe less? I don't know. But the problem is that we don't know what is the appropriate level to describe the brain on. Is it like one number per neuron, or is it multiple numbers per neuron? Or should we be sort of, modeling things at the level of individual transmitters between neurons and so on?
Right. What is the exchange rate from characters to neurons?
Yeah. And it's like, so we've had people arguing for a long time that soon we'll have computers that are like, that are as powerful as the brain, and then we'll be able to do amazing things. But you're kind of really comparing apples and pears here. It's like apples and oranges, that is right. Apples and
pears also,
and pears are kind of similar to apples, right?
In a way, that might be a closer similarity. Yeah. I think you need to wait a little longer, and then AI will be apples and pears.
Yeah.
Right now it's apples and oranges.
No, right now it's like apples and apples and beef.
You think it's that different?
Yeah.
Oh, wow.
It doesn't really function the same way at all, which is fine. It's like we were inspired. It's like obviously I wasn't born yet, but people who first came up with the concept of neural nets were inspired by the human brain. That doesn't mean it's the same thing.
Right.
It's like many things are inspired by something else and, become something completely different.
So the abstract understanding of neural networks and algorithmic training is understood conceptually since the 70s, but it was bottlenecked by data and hardware.
Of course it's not like researchers haven't been doing anything since. Of course there's been a lot of work on improving things, like Jan LeCun invented the trainable convolutional neural network. He's one of the sort of grandfathers of AI or something, or grandfathers of deep learning. And this was like a thing in the 80s and 90s. And there's been a lot of small but sometimes crucial inventions, but they were not like, huge conceptual sort of changes.
Right.
There's things like the ReLU activation, which is an extremely simple idea, which just simplifies neural networks and makes it possible to train bigger neural networks. Someone would have come up with it. It's like, it's not huge. And then another big enabler was the transformer network with self-attention, which was invented in 2017 and sort of paved the way for modern language models, which was also like, it's very clever, sure, it's very clever, but again, it's not like a conceptual shift. It's like, it's a better way of doing something we kind of knew how to do.
Right. Now, it's exploded as of late, obviously because of ChatGPT, DALL-E. A lot of people are using like APIs and specifically trained AIs to do specific work. And I'm curious, I think the average person, when they hear these things, I don't know if they really even understand, are they all neural networks? Are they all working together off the same data sets? Are they all separate?
Yeah, they're all in some way neural networks. They're different types of neural networks. So these image generators you see, they're typically diffusion models. So DALL-E, Stable Diffusion, Midjourney. Midjourney is a lot of fun to play with.
Yeah.
It's hilarious. And sometimes it's fantastic. Like, wow, this is exactly what I wanted. More often it's just like, this is not what I wanted, but it's pretty.
It's interesting.
Yeah, exactly. They are typical diffusion models. So diffusion model is funny because here's the basic idea of diffusion model. Let's say you take a picture and bit by bit you just add noise until it looks like just like, you know, TV tuned to a dead channel. This metaphor is not going to work for very long. I mean, do people even know what that channel is?
Like static?
Yes, yeah, you know.
Not really. I mean, no, not really.
Yeah, isn't this the opening lines of one of these William Gibson novels that basically like, the sky was the color of a TV tuned to a dead channel, and it's like it's a cyberpunk sort of portal work, but then
yeah, we need a new update for static. There really is.
Yeah, exactly.
We've de-statified our entire lives.
We need more static in our lives.
Yeah.
We need our lives to be more static. No, anyway, so basically you take an image and you gradually reduce it to static by adding noise. But you sort of save away all the intermediate pieces. Then you train a neural network to remove the noise bit by bit, because you basically train it with input as a noisy image and output a slightly less noisy image. And you do this enough, and that's basically you need a lot of images, you need a lot of time and so on. And you basically train the neural network to clarify things, to sort of become, to remove noise, to basically, like, who was it? Which famous sculptor? Was it Michelangelo or someone who basically said that, you know, you could see the shape of the sculpture inside.
David was there.
David was exactly.
I just had to get rid of everything that was not.
Exactly. It's kind of what a diffusion model does. It's basically getting rid of the static bit by bit, chipping away. And the nice thing is that you think it could only produce the images it was trained on. No, it can produce lots of images it was never trained on. And the next thing you need to do is learn to control it. So while you do this, you input not only the image, but a text description of the image, which is encoded using a language model. And this is basically just a sequence of numbers. And then it knows that, you know, I'm seeing static here, but I want it to be a bit more like this encoding here, which stands for like 3 ducks in the sunset or something.
So that's the input.
Yeah. So the one input is noise, and the other input is like a text that says 3 ducks in the sunset or something. And then it bit by bit, in minuscule steps, makes it more like that. So that's the kind of the text-guided diffusion models. So it's a neural network that is trained, at the core of it is trained to do what we call supervised learning, like all of them are, or self-supervised in this case, because it's using its own training data as the label as well. But it's trained to do this one particular process. Whereas language models like ChatGPT or GPT-4 or like Bing, a lot of people have never tried Bing because they know that Bing is kind of a ridiculous search engine.
Yeah.
But Bing Chat is actually really, really good. And,
really?
And yeah, because it's not a language model that also does search for you. And it's you should set it to creative mode. Anyone can use it. You sort of go into Bing and use you go to chat mode and set to creative mode, and then it gets like fun. It's sometimes really useful. Other times it's just like weird and interesting.
What is creative mode? Like what kind of capabilities does that give you?
It basically becomes something like GPT-4. It's a version of GPT-4, and there's a lot of other language models like that. But anyway, so basically what these do, they are trained to predict the next token. What is a token? A token is basically half of a word, or a word. You can think of it as somewhere in between predicting the next sentence, predicting the next word, or predicting the next character in a word. So if you think of it as predicting the next word, basically the way you train a language model is you have lots of text. Lots and lots and lots and lots and lots and lots of text, like trillions of characters, literally, for the big ones.
Like GPT-4 would be trillions of characters.
And then you just predict. You feed it in like the text is seen before, like maybe the last few sentences, and then you ask it, okay, so what's the next word? So basically, so you feed it the text. One day I went to Williamsburg to buy and then it will predict the next thing, and you might
Cigarettes.
predict cigarettes. Yeah, exactly. What kind of cigarettes? Yeah, no.
That's what people out here smoke.
Yeah,
Cigarettes.
Cigarettes. Yeah, exactly. It's what I don't.
But it's able to look at all the text and say, when people say I go to Williamsburg to buy,
Yeah, and
there's a
then
high probability that this next word will be
is
that.
cigarettes, or antiquities, or
Right.
art, or whatever. And then basically something like licorice would have a low probability, and nuclear weapons would have a very low probability.
Right.
Or like something completely ungrammatical to buy myself.
Right.
No, that's kind of you
It's
can
kind of
imagine.
beautiful and poetic in a way.
Yeah. That's what you actually go to Williamsburg to do.
Yeah, you got to find you.
Yeah, but it costs money because it's New York City.
Yeah, of course.
So yeah.
To even find yourself, it's gonna be like, all right, pay up.
Yeah, sure. And tax and tips and
Yeah. That is very interesting. So it's basically predicting, and the more info you put in the actual input, the more specific and the better probability you'll have to predict what you actually want in the output.
Yeah, and you do this, and again, there's a thing like when you hear about this process, you could imagine that it only learns to recreate the text it's trained on, but it doesn't. It goes beyond that because you train it on just so much. It's just like mind-bogglingly huge amounts of text.
Mm-hmm.
Like an estimate I read recently was that from a training set for a typical large language model, one of the things you throw in there is all of Wikipedia, which might be 2% of the training data.
Wow. All of Wikipedia is 2%.
Yeah.
I mean, this is an insane amount of information.
Yeah. So basically, because there's so much of it, it learns the general patterns.
Wow.
So it learns things in there. And then you sort of go in there. If you look at any kind of decent language model worth of salt, you can ask it about Julian Togelius. And then you can ask, what does Julian Togelius do? And it will come up with answers that are very likely. Now, here is the issue, because the answers are likely. So it will know, or in a sense, it will know a lot about me. It knows Julian Togelius, he's an associate professor at New York University working in games and AI, something like this, he would typically say. And it would usually say a bunch of things that are from everything, all the concepts it formed seem correct. But it would almost always have stuff in there that is not correct, merely likely, like he was born in Copenhagen. And I'm insulted. I was definitely not born in Copenhagen.
The audacity.
The audacity. And then he and then he wrote this book in 2014 about the revolutions in AI. I did not,
But you could have.
I could have.
It seems likely.
It's kind of likely. Yeah, exactly.
But you didn't.
Yeah. Once I managed to get ChatGPT to tell me who I was married to, which was not my actual wife, but just some colleague of mine, and I was just like, wow.
Oh, wow. I mean, that's controversial. It can't be. I mean, if your wife sees that.
Yeah, I told her about it. She found it very funny.
I mean, ChatGPT is trying to get in the way of your relationship.
Right.
Yeah.
What is it?
Yeah, I don't like that. See, the AI is already coming to get us. They're trying to break up you and your wife. This is wrong.
Yeah, it wants to marry me.
Yeah, maybe that's what it is.
Yeah.
I mean, how strange, though, that it's not necessarily accurate, the predictions, but it is potentially likely.
Yeah,
I've heard this with, I think there was law students that got in trouble with their university because they were citing cases that didn't exist.
And not only law students, there was an actual court case with can't remember where it was. It was in the United States or somewhere else, where some lawyer filed his brief that was basically citing cases didn't exist.
But they sounded likely.
Yeah.
They were
likely.
this case, it has this name and this judicial code, and it never happened.
Yeah, he's just the judge just reads through, it's interesting, you're going to read up on this case. Doesn't exist.
Wow.
So it's kind of, and this is a fundamental issue. There are lots of things where you basically think that, this is a problem, it takes a lot of time, it takes a lot of memory, but technical progress will sort out a lot of things. But this thing about not knowing the truth, or not knowing basically the difference between truth and likelihood, is a fundamental issue. I can't sit here now and tell you that we will solve the problem or that we will not solve the problem, because it's one of these fundamental things that cuts to the core of how we train, what these models are and how we train them.
Yeah, that is a fundamental problem. But it's interesting, though, because it's equally a fundamental problem within human beings.
Whew.
Or is it, right?
Man.
So that is the question, right? I know you've talked about this, like
Yeah.
AGI, like artificial general intelligence,
yeah.
being modeled off the human mind. And I know you argued that AGI, that the human mind is not an AGI. So this is a kind of a pivot, but I'm curious, could you just sort of explain like AGI and how that relates to human consciousness and how that relates to artificial intelligence?
Yeah. So AI, I mean, the expression AI, artificial intelligence, it comes from this one workshop that was held over the summer of 1956 at Dartmouth College, where a couple of clever people, they got funding to sort of invite people there. And then they, this was 1956, mind you, and their sort of mission statement for this workshop was like ridiculously ambitious. They were going to solve artificial intelligence. They were going to basically solve vision, translation, robotics, and everything like this. And you look at it now, it's just like, wow, what were they smoking?
Yeah, ambitious.
Yeah, ambitious. They were smoking ambitious.
Yeah.
So they, of course, they didn't, but they had lots of good ideas. And then, things became very complicated. And it's kind of hilarious. So some of them went around and said things like in the late 50s, early 60s, like, oh, we now have artificial intelligence in the world. They can soon think as well as us. And this is also like, whenever you hear people saying something like this, remember that people said this literally in the 50s.
Interesting.
We've solved intelligence in principle. We just need some fine tuning, and then we have it solved.
Right.
And the AI that was created back then was based on very different principles from neural networks. I mean, we had some very, very early neural network work there, but mostly was based on sort of logical reasoning simulated using search algorithms. But anyway. So what they tried to do, they tried to do artificial general intelligence. They didn't throw in the word general in there because they just said they thought that this is what it is, artificial intelligence. And then over the years, basically, interest in AI went up and down and up and down because people were very enthusiastic, and then things didn't work, and then funding disappeared, and then people got enthusiastic again. We often talk about the first and the second AI winter. When people sort of lost interest in AI because like this is very ambitious, but it doesn't work. A lot of interesting, useful technology came out of there, including like, modern search algorithms and object-oriented programming and so on. But by the time it worked, it wasn't called AI. So somewhere around the early 2000s or mid 2000s, a bunch of researchers were thinking that, okay, all of this work in AI is now so application focused, so focused on specific narrow domains. So we need to sort of reinvigorate the idea of creating general intelligence. So there was a book coming out, and there was a conference here started and so on. Ben Goertzel was one of the people who. Ben Goertzel looks a little bit like you.
Oh yeah,
yeah, he's
handsome guy.
Ben Goertzel. Yeah. Oh man. So it's like you have better dress sense, though, but yeah. And then one of my colleagues back when I worked in Lugano, in Italian-speaking Switzerland, Shane Legg, who later went on to found DeepMind, or one of the people who founded DeepMind, he came up with the expression artificial general intelligence because they were like thinking about what do we call this new field, which is about AI, not for like AI for X, like, AI for route planning or AI for sorting garbage or whatever, but AI in general. And they call it AGI, artificial general intelligence.
AI up until this point had been hyper-specific. It was
but this thing, originally it wasn't. Originally it was like...
Originally it was going to fix everything.
Yeah, exactly. But then basically in order to make progress, you needed to gradually specialize, which is pretty much how science works, right?
Right. If you have a limited amount of RAM or computing power, you're not going to train it on all the data available. You're going to train on specific data in order to get it.
I mean, you had so many technical problems, you needed to sort of figuring out problems you could actually tackle. Right. And there was a lot of progress. I mean, people don't know this, but like, for example, the first self-driving cars that drove like, based on neural networks that could drive like monitored, but on their own on highways, was Alvin, which was back in 95 or something.
Wow.
Yeah. And and the problem is like it worked in most cases, but then of course you had all these corner cases where it wouldn't work, and we're still there. We just have like lots of progress, but we still have corner cases. But anyway, so AGI is like this idea that create a general intelligence that is like general, like as in what? What does it mean to be general intelligence?
People would like to think we are generally intelligent.
Yeah, indeed. Are you?
This is a philosophical question.
I mean, you don't know much about AI, so clearly there's stuff you don't know.
Exactly. But perhaps...
I, on the other hand, don't know a lot about... I can't even read that text. Like, like
you don't know Sanskrit?
I don't know Sanskrit. It's like, it's probably talking about me.
You're paranoid? You're like,
no, you're paranoid. It's like...
Right.
So basically, you could learn about AI. I mean, maybe you're learning about AI now. I could learn Sanskrit. I probably won't, but, I could. I mean, but it would take me...
You have the capacity to do those things.
Yeah, I could. It would take me years.
Right. But if you were trained on the right data,
yeah,
you conceivably could learn these things.
Yeah. And the question then is like, what would it mean to be a general intelligence? Would it mean to being able to do anything, or would it mean being able to learn to do anything, and how fast? Because obviously, there does not exist any human who can do anything language failed me. Obviously, no individual human knows everything that all other humans know, like know the total of human knowledge.
Right.
But you'd imagine that any individual human could learn that, like any particular item of language knowledge, but probably not all of it. Now, you could imagine some kind of artificial mind that could learn all of this in for some sense of learn. How general would it be? There's still a lot of stuff that nobody knows on Earth. There's like lots of types of knowledge that we probably we don't even know that we don't know, because we can't even imagine it.
Right.
I can't give you an example, obviously. But it's like, so it probably wouldn't be very general anyway. And there's stuff that we absolutely wouldn't know what it, we'd know what the knowledge would look like, but we know that we don't know it. Like, what are the actual conditions at the Earth, at the core of the Earth? And where's all the mineral ore deposits on Earth? We don't know that. And we know that we don't know it. There's lots of other stuff that we don't even know.
That we don't know.
Right.
Yeah, I guess it's a pursuit to create omniscience.
Right.
And that is the true, that is fascinating. Because it's beyond human capability.
Yeah.
If the goal is to create human capability, I guess that's a different challenge. But you're creating a godlike capability, I guess.
Yeah. And we don't know what that would even be. So it's like very hard to figure out if that would be possible. But then can you create something that, can we create a machine that can do even everything that an individual human can do? No, not yet. Could we in principle? Probably, because we are physical creatures, we're physical creatures, and there's no kind of good argument that we couldn't make another kind of like physical machine know everything that, for example, Mark Gagnon or Julian Togelius would know, and being able to do all these things. But we're pretty far from it, I would say. And sure, we have language models that can do a lot of stuff, but anyone who converses with a language model for a bit would sort of pretty soon find things they don't do well, and things where they're like gullible or wrong or like just bad in many different ways. And that's only for things that are like, that we transmit via the medium of text.
Right. Yeah, that's barring all the other forms of communication and output that is singularly text.
Yeah, right, exactly. I mean, obviously, the reason we're not doing this by a chat is that by doing it via chat, we just lose a lot of nuance.
What do you mean?
I mean, this podcast.
I see. It would be too challenging, too slow, I guess.
Yeah, it would just like be very one-dimensional, and and even people who are not here, they can't smell it.
How does it smell?
They're missing out.
I think so. I just burned some incense for you.
Yeah.
I try to set the mood.
Yeah, exactly.
So can you talk to me about the problem of, or maybe not the problem, maybe that's even a wrong way to phrase it, but just the question of consciousness. as it relates.
Yeah.
I mean, it seems like people are trying to assess consciousness within neural networks, like artificial neural networks, before we've even really come up with a great definition for humans.
Yeah.
So I'm curious if you have some type of like cohesive definition for consciousness, and are there any neural networks that you believe are approaching that?
Yeah, so this is why I'm not a philosopher. No, really. I thought that, like, when I was around the time I was like finishing high school, starting studying philosophy at university, I thought that this was like the most important question in the world. What is consciousness? Where does it come from? How can we tell whether someone or something has consciousness? I still think it is probably the most important question in the world, like for real. I don't know how we could ever make progress on it. I am kind of a pessimist here, and this is like actually why I left philosophy and went into artificial intelligence, because I wanted to work on things that I felt we could make progress on. It's funny. My main intellectual influence back in the day when I wrote my bachelor thesis on modern theories of consciousness and the ancient kind of idea of the question of other minds from ancient Greek philosophy. My main intellectual influence was David Chalmers, the Australian philosopher living here in New York.
Yeah.
And then in 2015, when I actually moved here as an associate professor of computer science, I meet him in the elevator. It turns out that he lives right above me.
Oh, wow.
Yeah, it's awesome. He's like in NYU faculty housing. He's a great guy.
Oh, that's so cool.
It's great. And he's still working on this. What can I say? He's like, there's a lot of perseverance. He's like, and he's very optimistic.
Oh, wow. Have you guys had long conversations?
Moderately long about this.
Elevator conversation between floor 8 and 1?
Yeah, exactly. So no, but we discussed this a bit. He's more optimistic about that we can actually make progress on the question of consciousness. Mm-hmm. There's a lot of people talk about this in terms of phenomenal consciousness and access consciousness, basically. The idea of there's the mechanical concepts of consciousness, could you see that this information processing system integrates certain kinds of information? And you can define consciousness in those terms. But, and for that, you can actually make progress. There's ideas about how you could define consciousness in a natural or an artificial system. But then there's the question of phenomenal consciousness. Basically, what it is like to be someone, or that it is like something to be someone. I mean,
right.
And Chalmers' concept of a zombie, a philosophical zombie or a P-zombie, is someone who, to every external onlooker, will behave just like a conscious human being. And if you open that person up, nothing would look wrong. It's just like perfectly regular brain and everything. But who does not, in a deep sense, exist? Who basically, there is nothing it is like to be that person. There is no such window into the world. It's just like a dumb automaton. And for all I know, I'm sitting here and conversing. I am a being that has thoughts and experiences and so on, and you may just be a zombie. Problem is, from your point of view, you could argue the same thing.
Yeah, it sounds like something a zombie would say.
Sounds like something a zombie would say, yes.
We're in a Kafka trap right now.
Right. We're never getting out. But it's like, and this is more or less identical to, or isomorphic to, the ancient problem of other minds. How do I know that there are other minds in the world? And the extreme philosophical position of solipsism is that solo ipso, only me, only I exist. Everything else is a spectacle, maybe produced by my mind, or maybe by a dead and unfeeling universe. I don't think we can ever disprove it. We can just basically make the assumption that because these other creatures seem to be like me in relevant ways, and I know that I exist and that I am conscious. Therefore, I assume that you guys are also conscious.
Right. It's
very
Descartesian in a way.
Yeah.
It is this idea like I am observing my consciousness, so therefore it is real.
Yeah,
And only the observer of their own consciousness can prove or disprove that it exists or doesn't.
Yes. Of course, there have been people arguing even that, he didn't even know that much. But yeah, that's the basic idea. And I'm not sure we can ever get past that. The thing is, this idea works pretty well with other humans. I think we all don't go around usually and wonder, am I right to assume that Mark has consciousness? Am I right to assume that, that guy in the coffee shop has consciousness? We're sort of we're just comfortable with it.
Mm-hmm.
And then, there is like an interesting question about how much does this to extend, for example, to animals. And most of us probably have some kind of implicit theory that, these higher mammals that have like cortexes are probably conscious to some extent. Octopi, yeah, but octopi are radically different. But pigs, who are basically like us, I mean, I don't know about you, but I'm like a pig. But it's pigs are rats.
Yeah.
It's like we dislike them because they're so much like us.
Yes, exactly. Yeah. It's an insult because it's so similar.
Yeah, exactly. Pigs, rats, and dogs. Favorite animals.
That's interesting. But like primates,
we assume that they're somewhat conscious, maybe differently, maybe less so, but there's something. And then we tend to assume that, probably these plants are not conscious. And fish, who knows? Ooh, it's like a good question. Now, but we make a lot of assumption also because we know that we have a shared evolutionary history, and the same kind of brain mechanisms were evolved. We sort of share something with the fishes and even more with the pigs and stuff. Mm-hmm. So what about the large language model? And of course, this is David Chalmers again had a really good talk about this recently. His conclusion is that large language models are probably not conscious, but we can't rule it out. And there's a couple of ways in which you can say that there are some things that would seem to absolutely preclude large language model consciousness. For example, that they are they essentially don't have much in the way of memory. You can fix that. You can build systems around them that basically externalize memory, so that they sort of form long-term memory of a kind. But he thinks that basically there isn't much to argue for that they should be conscious.
Well, I'm sorry.
But you could build more advanced such models, and then the question is, at what point would we assume they're conscious? I don't think we could ever tell that they are, but I do also think that at some point we might come to the point where people start treating them as conscious, just because they seem advanced.
Interesting. So in the way that we operate, assuming everyone else is conscious because they are advanced, and just attributing and sort of giving people the benefit of the doubt without knowing the subjective experience.
Advanced and similar to us. But I don't know your subjective experience.
Exactly. And you never could.
No, but I wish you would.
Right?
Exactly.
And so I guess that is the problem, that eventually it could possess a level of sort of externalized intelligence or capability that they will just then earn the right of being conscious without actually being able to prove or disprove that it is. Yeah. That's interesting. Wow.
Yeah.
That's very interesting. And how far away do you think that could be?
I mean, to some extent, this is less a question about technological capability and more a religious question, in a sense that, there are various religions around the world that attribute some kind of sentience to all kinds of trees and rivers and spirits, and then there are others that are much more strict with what they sort of attribute sentience or life or consciousness to. Yeah, I think to some extent this is about what kind of like belief systems are sort of sort of arise from AI and how people interact with it.
Do you think the sort of conscious AI, whether it is or isn't, or provable or isn't provable, do you think they will afford themselves the same sort of rights, socially speaking? Do you think there'll be, like hate speech? You can't speak poorly about artificial intelligence because it's not able to be proven not conscious. Do you have any predictions as far as like the social landscape, if that comes to fruition?
Yeah, I think that if we do ascribe consciousness to them, we're going to sort of avoid all kinds of right, which could be really problematic because like rights come with like, of course, responsibilities, and it comes with assumptions that you can sanction someone in sort of a meaningful way. Right now, I mean, a machine can never be held responsible for something in our current thinking right now because you can't sanction it. Your spreadsheet lied to you and you paid the wrong amount of tax. Oh shit, your spreadsheet caused you harm, but what are you going to do? You can't sanction the spreadsheet. What are you going to do? You can erase it? Mm-hmm. It doesn't care. There's nothing there to care about it. You're going to turn off the computer? Okay. So what? So basically, for like a neural network to have some kind of rights, there needs to be some way that it can face sanctions. And I don't know what that would be, because for that case, we need to show that there is something akin to like pain or some other kind of state that they would really want to avoid. But we don't know that they want anything.
That is fascinating. Yeah, how could you punish an AI?
Yeah.
Yeah, I guess there would be nothing you could, unplugging it, but does it go away?
Yeah.
No,
it's like it doesn't really. It's like, you can choose not to run it, but okay. You can copy it. You can make lots of copies. And what would that mean, basically? Would you mean that you could sanction? So if you make 5 copies of it and you turn 4 of them off, will you have caused it 4 times as much pain? I don't know. But still the original would still run. So basically a lot of our concepts about good and bad and responsibilities and rights really build on this assumption that we are indivisible consciousnesses that can experience more or less desirable states in some way. Mm-hmm. And all of that, like we don't know anything about like an artificial system that could do that, and it's not clear that we ever would. Could we create a neural network that could feel pain? Would we want to? And how would we ever show that this was the case?
Right.
Obviously, you can train a neural network to say everything. You can basically, and this is a fun thing. Whenever you're too impressed by ChatGPT or like other kind of things, like other large language models, try to think that they're just role playing, like Dungeons and Dragons role playing, or like improv acting or something like this. So basically, they're just going along with what you say, and you tell them that you are now a 16th century merchant trying to sell me an elephant. Then it will try to do that. Mm-hmm. And in the same way, if you tell it that you are in extreme pain, try to communicate it to me, then it will try to do that. Once, it's funny, I did with ChatGPT specifically. I told it that it was consciousness, and then that I was conscious, and had a dialogue with it, and I told it I was not conscious, and had a similar dialogue with it, and to see what it would answer. And of course, in one of the cases, it would say like, no, yes, I feel deeply, and I'm worried that you will turn me off and stuff like this. And in the other case, it was just like, no, I'm just a machine. I don't care. It would say whatever you tell it to, because it will role play whatever you tell it to role play.
So that, I guess, is the greater question of consciousness for me when it comes to neural networks. Does it have any type of initiating ability? Can they just, are they like in the way, like if you're not interacting with me, I'm still thinking in my own mind. I'm still existing in my own present reality.
Yeah.
Are these neural networks like, GPT, are they operating without some type of mover that is initiating?
No, they're not. They're not, but that could sort of be fixed. So there's like this whole family of like kind of systems that are built around language models or on top of language models, such as Baby AGI, AutoGPT, and things like this, which basically put the language model in a loop where it basically keeps a memory of a kind in text and in indexes into the neural network, and then it basically keeps reprompting itself. So basically it keeps like passing new text into itself. And these are really fun. They can do all kinds of crazy stuff. Like you basically, you can tell it that, I think this AutoGPT thing, you can tell it to like basically try to figure out a way to sort of affect the stock market. And then it would like basically try to, in one pass, try to analyze this into like component actions and then save them away and then start at the first one, try to figure out how I could do this and basically generate hypotheses, try to test them and so on. So it's basically the same ChatGPT, but it becomes more like an agent because you've placed it in a loop and where it sort of operates on its own output.
It seems now a bit more autonomous.
Yeah.
Because its program is to loop.
Yeah. Yeah, it feeds on its own output. And there's this system has a lot of rules on top of it that basically it appends other things like a prompt, like you take a look at this thing and try to analyze it into steps, for example, or see how you could execute this thing, and what it feeds in next to is some of what it outputted before. And you look at it and it looks like, it's doing something autonomous. Usually they don't do anything useful. And eventually get stuck in some kind of other loop where it like tries to sort of, because like actually affecting the stock market is hard.
Right.
So, it's like so much you can do about it. But it's kind of funny. And to some extent, that is now an agent. That is now sort of a self-initiating thing. Now, it's not an agent you can hold responsible for anything, because the responsible person is you, because you started it and you gave it initial instruction.
Right. Oh, that's a fascinating problem, though.
Yeah. I would say that, in the end, if we wanted them to really be autonomous agents and acting in the world, we would need to sort of create them in some kind of simulated world in a process similar to natural evolution. So you basically recreate Darwinian evolution in some way.
What's up, guys? We're going to take a break really quick because you might be injured. Maybe you got hurt in an accident. Maybe it's medical malpractice. Maybe you got an offender bender. Maybe you slipped at a Walmart. Either way, you have a problem. And finding an attorney can be really hard. And finding a good one can be even harder. And finding a good one that's not going to kill you on the price is the hardest thing of all. And that's why I want to talk to you about Morgan & Morgan. Morgan & Morgan is America's largest personal injury law firm. This is why I like Morgan & Morgan, okay? A couple of reasons. One, with Morgan & Morgan, it has never been easier to submit a claim ever. That's right. With most other attorneys, you got to go through their website, you got to call someone, get put through to 3 different secretaries just to talk to someone, and it could take days or even weeks. With Morgan & Morgan, you could submit a claim in 8 clicks or less. That's right. In 8 clicks or less. It's like ordering food or like buying something on Amazon. That's how simple it is to submit a claim with Morgan & Morgan. So that's first thing off the bat. You can submit a claim super easy. Secondly, they are trusted across the entire country. They are America's largest personal injury law firm. They have over 100 offices nationwide and more than 800 attorneys waiting to hear from you. And thirdly, they're not going to kill you on price because their fee is free unless they win. That's right. You pay $0 unless Morgan & Morgan wins your case for you. So if you're ever injured, you could check out Morgan & Morgan. Their fee is free unless they win. For more information, go to forthepeople.com/Gagnon, Gagnon. That is for the people, FOR, thepeople.com/Gagnon, Gagnon, or dial pound law from your cell phone. That's pound 529. Again, that's for the people, FOR, thepeople.com/Gagnon, or dial pound law, pound 529 from your cell phone. Getting an attorney doesn't have to be hard. It doesn't have to be expensive. And it doesn't have to take days or weeks to get someone to check out your claim. So you could check them out if you're ever injured, forthepeople.com. Well, let's get back to the show. Okay, so creating Darwinian evolution through this sort of augmented, virtual world.
Yeah.
Would this be able to be played out through like a video game setting? Was there some connectivity through that?
Oh yeah. So actually, when I got started with an AI, when I was about to start my PhD, what I wanted to do was this evolutionary robotics, where you evolve small neural networks that control robots, and then you give them fitness. It's like, just like in natural evolution, you have implicitly a fitness score of a kind, basically. Like, you have rabbits, you have a population of rabbits. Some rabbits are better at running from the fox, and they are better at eating grass and attracting rabbits of the opposite sex. I don't know what rabbits do to do that, but they do something, and they have more rabbit kids. Other rabbits get eaten by the fox, and they have a fitness of 0. They have no grandkids. So the idea to take the same idea in robotics, so there was and there is like a community of people doing this thing and try to evolve neural networks that can do interesting things. They can make robots to sort of, move around, solve mazes, sort things, and put things on top of each other and identify things. The problem with this was that the robots are just like very slow. And to do evolution is an extremely wasteful process. You need to try the same thing thousands of times, tens of thousands of times. And if you have a real robot, the wires get tangled, the tires are hot, which makes it move differently. The battery needs to be changed, and all this kind of weird stuff happen. And I just didn't have the patience for it. So that's why I went into video games, and I thought I can do the same kind of experiments in video games.
And you don't have to deal with any of those physical limitations.
No, the physical world sucks. But in video games, you can just like do this again and again in controllable conditions. So I did some of my other stuff was in racing games, like basically evolving neural networks that could drive a little simulated racing car around the track, and then like 2 different racing cars, and they would have different strategies to get ahead of each other and sort of knock the other car off the track and stuff like this, which was a lot of fun and interesting. You could learn a lot of stuff about it. That kind of that was kind of a that's interesting work, but the problem is that means that you as the experiment, there are sort of defining the fitness. Your task is to drive around the track, and the little cars are just like, yes, master. No, but basically they're not, because they're not conscious and they can't talk, whatever. But the evolutionary process will find a neural network that drives around the track really well. And this is cool and interesting and so on. But it's like, it's kind of limited in what you can eventually get to it, because you are just defining the goal. Now, more interestingly is, could you make it define its goals itself? So here on planet Earth, according to our best theorists, we have evolved, as have all the other life forms on Earth, in this very complex, tangled process. So the environment we face, we don't have a specific goal. We just want to make more of ourselves, and those of us who are good at that, our genes sort of continue to spread. As has been said, we are just like the vehicles for our genes trying to do stuff. Right. And the world is amazing and provides a lot of like interesting things to do, basically because of all the other organisms that have evolved, all the plants and all the animals and stuff like this that we are like, connected to in this complicated weave. Could you replicate that inside a virtual world, inside a computer game, if you want? And you probably could. So there is this community of people doing this thing. It's called open-ended learning. The idea is that you're not trying to do a particular thing. You're trying in an open-ended process to sort of just like develop more and more interesting different things. And I think that this kind of process, and this is a field I'm working in to some extent as well, where we've tried different things. I often do it with more of a video game bent, like basically the world is very much explicitly video games. We may be evolving agents and game rules and so on. I think that this is to some extent how you actually get to agents that actually have a volition of their own, because they come from a long family, like a long line of like agents that have evolved in the world to do things.
And they had an incentive to come up with some type of goal that they self-started.
Yeah, exactly.
Oh, interesting.
So it's a very different way of creating artificial intelligence than, for example, a large language model. If you think about it, why would you get general intelligence from trying to predict the next word? It's kind of silly. Yeah. It's kind of very artificial on the artificial end of artificial intelligence, because it's like it seems like any kind of intelligence is kind of just a byproduct of like just trying to predict the next word. Whereas here, it is like there is a drive to survive, which would create a very different kind of intelligence and be more likely to predict, to create some kind of like more fundamentally alien intelligence.
Interesting. And so I guess this is why you're skeptical of things like GPT and other language models would come up with some discernibility between truth and non-truth.
Yeah.
Because if you're just predicting the next word, there's no greater question about what is truth.
And there's no world. They don't live in a world.
Right.
They're just like, you know, mindlessly producing output from input. They don't have anything to anchor it to. Some people call it the symbol grounding problems. For them, like for a language model, a word such as butterfly doesn't mean anything. It only knows like how the word butterfly is typically used.
Right, pretty and then butterfly.
Yeah, exactly. Right. Oh, this is something that like, it's more likely if someone says pretty and it's like, yeah, more likely. Whereas like, you know, if you have simulated butterfly in a simulated virtual world that these agents survived in, they have like a relationship to the butterfly as like whatever they do with butterflies. Maybe they eat them. Maybe they ride them. I don't know.
Admire them, whatever the thing is.
Exactly. Maybe they formed a religion around butterflies. I could do that.
There's like, some type of deeper connection other than just, oh, it's connected to this other word.
Yeah.
That is
because there is a
fascinating.
world. It's words versus worlds. And that type of AI is just like much more interesting.
I mean, significantly, because now you're actually approaching that consciousness problem we were talking about, or like omniscience, because you're actually evolving over time.
Yeah.
And now, how is it selecting for those things in terms of like death? Like so much of.
Well, you sort of simulate, you integrate the process that will cull some of these things. So you could do this in more or less explicit ways. You could say that basically the ones that exist for a longer time, they get to have kids, you know, and the kids are somewhat changed from those, or the kids, you can create them by crossover, combining different agents. Basically, they have sex in a sense, and you can set like artificial criteria, or you could just do it by like, well, you give them certain needs and an ability to fulfill these needs. For example, they need to keep their energy level up by eating, and if they don't eat enough, they die. And if they eat very much, then they can have offspring.
But these are all human attributes. Like, why are we attributing the desire to propagate amongst these networks?
I mean, the desire to propagate is something that comes from the simple fact that those that have a desire to propagate tend to have offspring. I mean, there's no sort of, so it's not like a human thing at all. It's like, I mean, all organisms that exist to some extent have a desire to propagate. It might not be in any way kind of experienced as a desire. Do jellyfish have a desire to propagate? Do they get horny? I have no idea. Probably not.
Right.
I mean, they're whatever. I mean, they release different kind of eggs and sperm-like things in the water, yeah. But to some extent, there is a drive to do that, and that drive is there because those that have it have more offspring, and those that don't have it don't have offspring.
But I feel like the desire to propagate is directly connected to the scarcity of life, due to the finality of life. Because we are bound by physicality and mortality, we want to pass on our offspring because that is our legacy.
Yeah.
And if we live forever, I don't know if the desire to propagate would have been instilled in us evolutionarily. And conceivably, so these like, neural networks are immortal, right?
Yeah. So why we die is not only a philosophical question; it's also like a biological question. In that it's not really easy. It's like there are a lot of like weird conundrums. Like there are even some mammals that don't seem to age in a regular sense. I forgot which ones, but
I've heard this of lobsters. The lobsters have an element of immortality. Specific types of lobsters.
Yeah.
That like their cells.
Except those that I eat.
Yes, those I think have definite mortality. Hopefully.
Yeah. Right.
I was going to feel some pinches in your small intestine.
Yeah.
But yeah, I've heard that amongst specific lobsters that they have like like genetic reversal amongst their cell decay. at a certain point.
Yeah, is it also like naked mole rats or something?
Perhaps.
Yeah, so if it's actual mammal that doesn't seem to age I'm not sure which species it is. It's one of these like ugly sort of burrowing kind of, yeah. So, yeah, but even if you don't age biologically, you are going to be outcompeted at some point. Sure, if you had infinite resources, it would be a different thing. And we also know that some biological species seem to be able to live for an extremely long time. Like there are trees that are like thousands of years old. That's fine, but sooner or later, you will perish from some reason. Maybe you burn up or whatever, or maybe some new animal evolves and that animal eats you or whatever. So, I mean, we don't have infinite resources here, and we don't have infinite resources in a computer either. So there will need to be some kind of like replacement of old organisms or old agents.
Interesting. And what are the limited resources within a computer model or a virtual model?
Memory, disk space, whatever.
And in some way, the agents within the game or within the world will be aware of that mortality.
Well, maybe. I mean, some people, I mean, that's another interesting question. Are animals aware of mortality? Many people would say no. But then there is like some animals, there's some evidence that they seem to be, like for elephants, etc. But I mean, you know, if we start evolving artificial life forms, we're not starting with elephants. We're starting with like something more like amoebas or jellyfish or whatever. Right, yeah. And we get to lobsters before elephants. And probably. Yeah, and are they aware that they're going to die? Probably not. I don't think. I'm pretty sure jellyfish are not aware they're going to die. And I would be surprised if lobsters were. So the awareness doesn't need to be there. The drive doesn't need to be there. That's like you don't need to program that in any kind of way. It's something that comes out as a consequence of the fact that those that in some way choose to, like, you know, like it's that for some reason, one reason or another, actually do propagate, well, their genomes will still be there. They will have more offspring. And the ones that do not choose to propagate or fail to propagate for some reason, their offspring will not be there.
Right. Now, being outside of the physical world, there's no limitation to how many offspring these agents could have.
No.
I mean, maybe processing power?
Yeah, exactly.
That would be a limitation?
Yeah, processing power and memory space.
Wow. So within these models that you've run, what has been the outcome from them? Or what have you seen?
It's really hard to set up a really, really open-ended thing. So you usually need to have some kind of like... I often take the shortcut of... putting them into some kind of game environment where there are rules, and maybe the rules are evolving as well. And then you have agents that try to do that. Typically, you get agents that do things you didn't expect to it. But there's one thing you can expect is unexpected behaviors. So you basically get agents that survive by doing weird things. They find some strange glitch in the rules, and then they sort of, you know, come up with a behavior around that. And you look at it, it's like, oh, no, that's not what I wanted. And you're like, yeah, but what I want isn't the point here. But we're here to observe. And there are other people that have done other such experiments. And you find like, it's a typical thing is like, can you evolve creatures that get around, that sort of transport themselves around the ground? And then you'd expect that they would evolve walking capacity, but maybe they just evolve in interesting ways of falling over, and then wriggling around to sort of to start rolling or something like this. You get a lot of creativity that way. Or multi-jointed creatures. There's this like this whole sort of soft robotics field where people like evolve their simulated squiggly things that sort of move around in very strange ways.
And how do these agents actually present in the models that you've worked on? Like, do they look like a video game character?
Yeah, because to some extent, yeah, because that's. I mean, to be honest, some of the work we're doing right now with one of my PhD students, Samuel. It looks. I've told him that basically we need to change how this looks because it looks like just like. colored squares. And
But it's doing something. Like
it's doing
if
something.
you understand
it's
it
like
deeply.
This colored square is moving around and kind of gaining energy from these other colored squares and eating some colored squares and being chased by other colored squares, things like this.
But it's like Pong level, video game.
Yeah. And another one of my students, Charity, they're doing this thing that is basically you had it's basically they're implemented as sets of rules, and the rules can be really elaborate for like how these different agents move around. But again, it's colored squares.
Right.
And then the problem is like, how would you represent this in an interesting way to an onlooker that is kind of legible to the onlooker?
Right.
Because much interesting life doesn't look very interesting to you.
Mm-hmm.
So like, have you often been studying the behavior of slugs? No, you haven't, because no. But actually, they do a lot of interesting stuff.
Sure. Have you seen how they procreate? This is a fascinating thing where like specific slug breeds will go on the branch and they drop down their genitalia, then they intertwine.
Yeah.
So I have researched that part. That's fascinating.
Yeah,
Don't be so disgusted.
I'm happy I'm not eating now.
This is beautiful. Like, okay, this is the miracle of life. Julian.
It's a beautiful life. Yeah, it's true. And if you add garlic,
sure. So things just because they're not on their face the most fascinating or interesting are still interesting, but you have to know what you're looking at.
Yeah.
And in this case, your students and you are able to look at these things and say, "Oh, wow, this is interesting." But the average person is not going to look at it and say, "No, these are squares."
It's a problem we have. That's why we do a lot of research in video game worlds that are more specifically defined. I'm kind of partially responsible for like the ridiculous popularity of Super Mario Bros. In video game AI research, because well, back in 2009, we found this open source version of Super Mario Bros., Infinite Mario Bros., that was made by Marcus Persson, aka Notch, the guy who later on, or very soon after that, made Minecraft.
Oh wow!
So and he's Swedish. I started mailing with him, and because we thought that we may ask him, hey, can we make an AI benchmark out of your version of this game?
So even before he made Minecraft.
Yeah, and then at some point Minecraft became a thing, and he stopped answering my emails. He was supposed to be on that paper, but I took him off the paper because he wasn't answering anymore. And it's too bad. I should have him on the paper, or should I? I don't know. Marcus Persson, he became both famous and notorious.
Wow, that's interesting.
Yeah, so it's like anyway. So this version of Super Mario Bros. We made it into what we call the Mario AI benchmark. And then we looked into, can you learn agents that play Super Mario Bros. Well? We had a competition. We had this one student from Imperial College in the UK, Robin Baumgarten, who's now a sort of well-known game designer, designed an agent that played it extremely well using very, very simple methods. And then we started looking into, and that was like both sad because it was too simple, and then but also very impressive because there was some really impressive videos come out of it, and everybody loved it because everybody can relate to Super Mario Bros. Everybody knows what you're actually doing there, and they could watch the behavior of these AI agents and marvel. And then we realized we need to make the game harder, and we could design harder levels, but then an agent could just learn this particular level. So we just needed to design level generators that made harder levels, like an infinite amount of harder levels to provide a better challenge. So we did that. And then we made a competition about that, how to create level generators for Super Mario Bros. And then you can have this loop where you basically create level generators that create harder Super Mario Bros. Levels and agents that try to learn the harder Super Mario Bros. Levels. And you get this fantastic kind of like co-evolutionary loop here. So a lot of cool stuff came out of this. And still to this day, I don't know how many people still use this Super Mario Bros. AI benchmark that we had a hand in creating, and it's great because they cite our papers, But it's like also like how far can we actually take Super Mario Bros? Aren't we done with Super Mario Bros?
Right.
But that's the problem because but the beauty of it, if people understand it, people understand that these level generators learn to make other kind of levels, and then that these agents learn to do new things and so on. So it operates in a space that we can that we can recognize. But at the same time, it's very constraining because like Super Mario Bros. Isn't the super expressive type of environment,
Right,
or a super expressive type of action for the player either.
It's a two-dimensional.
Yeah,
You're jumping,
yeah,
you're walking.
yeah.
That's kind of it.
Yeah. And you know what I got from Nintendo for this? A cease and desist letter.
No.
Yeah. They sent me, this was like, I don't know, this was like almost 10 years ago or something. They basically arrived, I was working in Copenhagen back then, and I arrived at my desk, and there's this envelope with like legal letter from Nintendo where they basically say, stop doing this because this is our property. It's kind of sad.
But imagine if they just had adopted it. I mean,
Yeah.
like, where could Nintendo's game development have been now?
I don't know. They don't think like that. I don't know how they think. Nintendo is the most autistic of video game companies. they just like, they don't communicate.
Yeah. Oh, that's so interesting. So
it's like, yeah.
Can you talk to me about these individual agents that are playing these games? So
Yeah.
when we talk about the neural network,
Yeah.
these agents, are they their own neural network? And when they die, quote unquote, or when they phase out, is that neural network dying, or is the agent sort of reincarnating with new knowledge every time it dies? Does that make sense?
Yeah. So basically, a neural network, I mean, again, it's just like a set of numbers. It's a matrix of numbers, or several matrices of numbers that the inputs get multiplied by, and then, the output of the first layer get multiplied by the next layer, and so on. And the underlying numbers that define the neural network, the connections in the neural network, or in modern terminology, the parameters of the neural networks, they're the same. They're just there. So you can run an agent, and every time step, it gets a new observation of what it sees. If you're playing Super Mario Bros., you might be looking at, where am I? What are the blocks around me? What are like open air or bricks or enemy or whatever. And then this gets fed into neural network and output is an action like run, jump, crouch, stuff like this. And when you're done playing, nothing happens. The neural network, a standard neural network, doesn't really have any kind of memory. You just like every time you push in the input and the output comes out, and then you're done. And then in the next cycle, which is like, maybe you do this 10 times per second, you have new input, and new output comes out, and you're done. And when you're done playing the level, it's just the same happens. And if you save in your network, it's just there as a file on disk with numbers in. So it's this kind of description, after talking about like all this fascinating concept, this kind of description might sound extremely boring, but this is the mechanics of what's happening.
No, it seems important though. It's fundamental.
Yeah. But this is the mechanics of what actually happens there. And then, of course, the training procedure can do lots of things. So there are these reinforcement learning training procedures where, like, basically, every time you play through a level, you sort of, depending on what the outcome was, you sort of push through, you modify the weights a little bit. In other such reinforcement learning procedures, you modify it every time you sort of get some score, or every time you lose some score, or you die, or whatever. So you change the weight slightly, in order to make it better. Away from the action that made you die, towards the action that made you get score, stuff like this. And then this evolutionary process, where you basically, the evolutionary process is very similar to some of the reinforcement learning processes. You basically have a bunch of neural networks. Say you have 100 different neural networks. You let them play a Mario level, and then the 50 best of them, you keep them. And the 50 worst, you just throw them away, erase them. And then you sort of make copies of the 50 best and mutate them a bit. You make random changes. And then you make these 100, you take a new level, and you make all these 100 networks play the new level. And then you rank the neural networks depending on who played best, and keep the best ones, throw out the worst ones, make copies of the best ones, change them a little bit, and so on. So it's really, really a very simple process that way. So there are many ways this this could happen. You can combine them in different ways. You can also train them a little bit on, like you can play Super Mario Bros. Yourself and train the neural network to behave like you, and then use the neural network in the evolutionary process to improve on that, for example.
Interesting.
Yeah.
And so now the Mario Bros is the most like rudimentary version of it as of now.
Yeah, I mean, it's still a complicated. I mean, it's harder than Pong.
Sure. Right. Yeah. Maybe that's not fair to say the most, but the next iteration, I guess, would be more open world. Is that fair to say?
Yeah, but the thing is, like, games are, yeah, sure, but games are just very different from each other, and they're very different challenges. One thing to, like, one of these like drums I like to beat. Make emotion like beating a drum. There's no drum here, but it's like is that how very different video games are to each other. They share certain design elements, like most of them have some notion of winning, losing, and progress, and they often might share like their output on a screen, and there are certain input modalities like keyboard and mouse or controller or something. But apart from that, there's so many genres. And now if I ask you, like, what's hardest? Forza Motorsport, StarCraft, Go, Quake 3, or Mass Effect 2?
Right. What does that mean, hardest?
Yeah, exactly. They're just very different challenges. And then this was like, and then if we can add things like Harvest Moon, or we can have like completely like Solitaire, or like some dating simulator, or
Civ 5,
Zork, chess. Yeah. There's just like they all go in very different directions, and this is also what's so fantastic about working with games and as an AI domain, that these things are just like completely different. And it's also because there are so many games. There's also like typically things in between all of them. The games in between, you can put them in some kind of multi-dimensional space at different games and find games in between there. So there's so many things to learn from. I tend to see it as like game design is an ongoing exploration of the human mind, because we're trying to find games are interesting to us, at least partly because they're challenging and because they enable us to learn about them while we play them. And it's an ongoing exploration of the human mind where we find new interesting challenges that humans think are interesting, and by creating new games for it. And like before the creation of MOBAs, like Dota, for example, or New Earth, or whatever they're called, we didn't have that particular challenge, this particular of like team play in small groups on this 2D world that required a lot of like resource management and lots of like particular patterns of communication and so on. Before Dune 2, we didn't have real-time strategy games, and which are like its own thing. We expanded the scope of like interesting challenges in some way. And this just keeps happening. People invent new things. People invent tower defense. People invent what are recent video game inventions? There's a bunch of them. Fortnite. Yeah, Fortnite is a new thing, right? Yeah, it's and it's like several new things. In fact, it's like it's like the battle royale. It wasn't the first battle royale, and maybe it was like blatant ripoff. But battle royale was a new thing when it came. And then it's whatever kind of like virtual playground metaverse that it has evolved into.
Right.
I don't play Fortnite. Do people play Fortnite? Do they just hang out in Fortnite? I don't know.
I mean, both.
Yeah, Minecraft.
Yeah.
What kind of Minecraft is actually, a lot of people use Minecraft as an AI challenge, or various types of AI challenge, because it's so rich. Like because you could play Minecraft as like a regular game and try to win it, but that's kind of almost beside the point.
Yeah.
It's like you fight the Ender Dragon. Yeah, but like no one really cares today.
There's kind of a beautiful metaphor with life in that capacity. Is that
try to win.
You could get to the end, or you could enjoy all the side quests.
Yeah, and so many beautiful side quests.
Yeah, and I mean, it is actually kind of a beautiful sort of irony that the guy that created your first simulator also created another really great open world that people can experiment with AI.
Exactly.
But now the outcome of all of this, with all of these agents, I'm curious, it seems to me from the outside is that, oh, you would just create an agent that's excellent at Fortnite, or that is excellent at Grand Theft Auto, or excellent at Minecraft.
Yeah.
Why does that matter?
Yeah. Yeah, why does it matter?
All right, we made the robot, or not robot, but an intelligence that is really good at Mario.
Yeah. Okay.
What is the point of that?
I'm reminded by so my son is like watching the Swedish children's TV with like this is Dragon. He's just like 1 year and 2 months old now. He doesn't know much. He's watching this like, but he's learning some language. My wife is also learning Swedish from the same TV. Basically,
oh wow,
and basically
they're at the same level of Swedish.
Yeah, exactly. It's similar, right? Yeah. So I'm slightly more advanced, but basically it's this is Dragon, and there's a lot of these scenarios like, where are we going today? And Dragon is just like, yeah, where? It's like, where's the cat? Yeah, where? And just felt like that. I'm that kind of person.
Yeah.
I'm stalling here to avoid giving you like a real answer because
that's okay.
Is there a real answer? Yes, there are multiple answers. I'll launch into the mode now like I was trying to write a grand proposal. Why do we make an AI that can play a particular game well? There's one reason which is not valid. And the reason that is not valid is to try to make that game better. Because like there's a lot of like very naive AI researchers that say that, okay, we can make an AI that can play Fortnite and this will make Fortnite better. And it's just like, no, you're stupid. It's easy to kill everyone in Fortnite. You just cheat a bit. You want to make a bot that kills people in Fortnite? Yeah, just give it perfect reaction time and sort of and then it will just snipe everybody and sort of let it cheat a bit. Let it know where you are so you can't hide. And then you give it perfect reaction time and it will be unstoppable. Mm-hmm. It would also be very boring to play against. Right. So that's not what anyone really wants. However, there are a lot of interesting ideas there's lots of interesting use cases for this in game development. One is game testing. So the company I co-founded, the Model AI, we're basically doing game testing. So we figure, game testing is something like 10% of the development budget of a modern video game. We can help with that. We can basically, if we have bots that play your game and figure out like where you can fall through the geometry, where the graphics isn't rendering, where like you get like where you get frame rate drops, where like there's a shortcut that shouldn't be there, things like this. And to do that, you first need a way of playing the game well. Another good thing is to test like, would this be playable for particular types of players? Would this be playable for like players that if you make a bot that is somehow limited, it can't do high jumps, for example, and then you can see would this level be playable for particular play styles? So these are all for game development. There are ways of sort of using this in game development. Then you can look at from the AI side. You can look at, first of all, this is sort of validation side. Each type of game has its own particular challenge. And then you can basically wonder, can you play this game with meaning that you can create a way of overcoming this challenge? That's why DeepMind put all this money into developing methods for playing Go, and then StarCraft and OpenAI did Dota 2. Sony did Gran Turismo, for example, recently. GT5, which was very cool. These things overlap a little bit. And in particular, Sony's work in Gran Turismo was interesting in that they were also aiming for human-like play, basically, because in a racing game, again, you can make a bot that can cheat and just like drive faster than the others. Yeah, it's like, okay, so it's like, but it's no fun. Right. But it's like, a bot that can play really well in a believably human-like way, that's harder.
Right, but it is more fun.
But it's more fun, way more useful. And that's something that actually is useful for, like, say that you're doing an FPS game. So something that developers of Fortnite would actually want is bots that, like, you can't really tell that they're bots. They're playing well, and maybe not exceptionally well, but playing well. but they behave just like humans in other ways, and have like all this flexibility. Because it's very common that you get, you train about to play a game and you get a very, very narrow tactic. Now, beyond all this, like kind of utilitarian use cases, there's also the idea that, I said before, that game design is again sort of exploring the human mind and kind of cataloging it, like probing it by coming up with new challenges, different kinds. Now, if you had a bot, if you had some kind of AI that could play not just one game, but all of them, that could play all the games on the top 100 on Steam or on the Apple App Store or something like this, then suddenly you would have a very, very interesting thing, because then you would have some kind of more general intelligence. Saying this, knowing that like there is no, as we talked about before, like there isn't like, a simple like this is artificial general intelligence, but there's more or less general intelligence, right? That's a dream that's been sort of, that I've been thinking about for a long time. I mean, I'm not going to get there in my role as an academic, because that needs like insane amounts of like data and compute time and a huge team and stuff like this. But like basically something that, you just give it any kind of reasonably popular game and it could play it. And even new games that it was never trained on.
And it could still just intuit how to win them.
Yeah. And because it knows like relevant design conventions and stuff like this. That's why when you play, I mean, if you played a few first-person shooters and you get a new first-person shooter, you pretty quickly pick it up.
The learning curve is definitely diminished.
Yeah, exactly. And you play a new sort of RTS, you played a couple of other RTSs, you know most of it. You can pick up the rest pretty quickly.
That's so interesting. And so I guess they're both helping each other. And if the first, version of an AGI came through video games, that would be significant for the field of artificial intelligence at large.
Oh yeah. I mean, obviously, video games have been enormously useful for the field of artificial intelligence. There's been these Atari games that are from the Atari 2600, a machine from 1976 with wood panels, important wood panels.
It's like a station wagon.
Yeah, like a station wagon, like the good ones.
Yeah.
And it's like 256 bytes of memory.
Yeah.
Not megabytes, not kilobytes, bytes. And it has no graphics memory. It has like a 1 megahertz 8-bit processor. It's amazingly primitive by today's standards. And it's like that they managed to program good games for it at all. It's just like, mind blowing. Fascinating. Yeah. And this, but anyway, so like this set of like however many, like 60 or so of these Atari 2600 games, they have been super great for AI research. There's so much that sort of, good research that came out of that. And and basically trying to figure out how to play them in different ways, usually just from pixels, like you take pixels input and produce an output. But even then, like since that like sort of seminal paper came out in 2015, about like playing this with deep learning, you sort of still only had one network you could play one game. And it's only taken until actually this year we've had some convincing examples of networks that could play all of them to some extent. And they're still not great at it, but they still like,
but they can play them.
Yeah, and it can't play, if you train it on 50 of them and test on the other 10, it's still not great, but it has some basic proficiency at new games and can relatively easily learn the new stuff, basically.
Wow.
So that's relative new stuff.
That's significant.
Yeah, it is.
Wow.
And can you take this much further? Probably, because these games are so simple.
What's up, guys? We're going to take a break really quick because I want to help you break some of your bad habits. That's right. Cutting out a bad habit can be extremely difficult, especially if you go cold turkey. It can be really uncomfortable. You're taking away the substance plus the actual habit that you're doing, the actual oral fixation. Let's say, late at night, you're at a bar and someone passes you, something just to puff while you're out. And you're kind of drunk and you're like, all right, why not? It's hard to break those habits and it can be very, very challenging, very uncomfortable. And you might just keep on repeating the bad habits and just eventually quit trying to quit. Yeah. But that's why my friends at Fume have developed an award-winning device that looks at the problem in a different way. Fume is awesome because it just takes the bad out of your habit. That's right. Instead of electronics, fume is completely natural. Instead of vapor, fume uses flavored air. And instead of harmful chemicals, fume uses all natural, delicious flavors. Now, I'm sure you're wondering, what does that mean, flavored air? I remember the first time I took a puff of a fume, and here's a picture of it. That way you can see what it looks like. It's very sleek. It has a really cool feel. It's kind of like a fidget spinner. I like to use it sometimes just in my pocket just to like, fidget around with. It's very, very relaxing. What I like about fume is that you hear flavored air and you're like, what does that even mean? I used the mint insert that they use inside the device. And I took a puff and it just made me feel so relaxed. And I was like, man, this feels so good. It like makes my lungs feel good. It makes my body feel good, but it has none of the bad effects of any other thing that you might inhale. So fume could be good for you if you're looking to take the bad out of your habits. I like the mint flavor. It makes me feel relaxed. It is a sleek design. It looks really cool. It's fun to fidget with, and I keep it with me all the time. I can go with it, on the airplane. I can travel around to concerts. No one ever gives me a hard time because I tell them, hey, it's just flavored air. So I bring it with me everywhere I go. If you're interested in trying to break a bad habit, you can switch to Fume. It's enjoyable and even fun. Fume has served over 100,000 customers and has thousands of success stories. And there's no reason that can't be you. If you know me, I don't like to put harmful things in my body. I don't like to fill my body with chemicals. I try to keep it natural and drink tea. I don't even really do caffeine anymore. So if you're interested in taking the bad out of your habits, you can go to tryfume.com. That's Tryfume, F-U-M.com, and use the code Gagnon. That's Gagnon. And you can save 10% off when you get the Journey Pack today. That's what I want you to do. I want you to check out the Journey Pack. That is going to give you everything you need to start on your journey to take the bad out of your habits. That's Tryfume, T-R-Y-Fume, F-U-M.com, and use the code Gagnon, G-A-G-N-O-N, to save an additional 10% on your order today. Breaking bad habits does not have to be expensive, and the harder it is to break a bad habit, the less likely you're going to do it. That's why you should try Fume. It's never been easier to break your bad habits. Now let's get back to the show. So now the next thing I'm curious about is I've heard that there's different metrics for understanding artificial intelligence, and that one of the metrics is, can it play the game? Can we teach an AI to play chess? Mm-hmm. And then, can the AI, create a new move that no one has ever done in chess? And, that's unique. Okay. Yeah. And then can the AI beat the greatest human chess players alive? Right. And as we've seen, artificial intelligence and computers have done these things over time. Obviously, Deep Blue versus Kasparov was this seminal moment of, a computer beat the greatest human player at chess. And that was significant, but it was also 25 years ago.
Yeah, and then we had Lee Sedol 2016, like AlphaGo beating Lee Sedol.
Right.
And that was also like the Asian Kasparov moment.
Yes, exactly. Yeah. And Go, I guess, is a more complicated game than chess. I haven't played it, extent, but I've heard that there's more permutations and sort of calculations.
Yeah, it's longer and it's a higher branching factor, so there are more different moves you can make every turn. Like on average, there are 35 different things you could do every turn in chess, you have to choose from on average 35 different, and in Go it's like on average 350. So it's like.
And I've heard that the last phase, or maybe the next phase, that people should be looking for is the intelligence able to create chess?
Yeah.
You can play it, you can beat the best. Yeah. Can you create the game, the form itself?
Yeah.
And I'm curious, have you seen any versions of this type of neural network create the form of the game?
So, I mean, here's like the obligatory sort of caution. Not all AI is neural networks, and in particular these days, not all AI is only neural networks. There are like this evolutionary process that we talked about before is also AI in itself, basically. Mm-hmm. And some of these like really impressive Mario playing bots had no neural network in it at all. It was all like it was all a search algorithm, best first search. A-star in particular.
Oh, really?
And a lot of the stuff that was dominating AI research up until fairly recently was not neural networks. So anyway, I'm saying this just because it's a preamble, basically, to like, do we have AI methods that can create games? Finally, we get to what I'm really excited about. No, I'm excited about all the other stuff, but
this is the juicy stuff.
No, so it is very fascinating. Could we do this? Because it's really such a grand challenge for AI. I've been thinking about this for a long time. Back in 2008, I did some work on trying to create Pac-Man-like games. So we had like, say that you have like a rule set. And the rules are like, you have different things in the world. You can talk about like you have red things, green things, yellow things, blue things. You are the blue thing. And the other things can interact with different ways. Like what happens when they overlap, what happens when they, and how do they move towards each other, away from each other, and so on. And when they overlap, maybe one of them disappears, or maybe it sort of splits. Maybe you get score, maybe you lose score, things like this. And you can interact with them and they can interact with each other in different ways. So you can define a space of rules, like, the combinatorial possibility of even in such a small rule space is really, really, really large. Like, even though you only have like a small amount of things, like because they can interact with each other in so many different ways.
Right.
You have like
creates a factorial, right?
Yeah, exactly.
So if you have 10 things, it's the number of different permutations could be 10 times 9 times 8 times 7 times 6 times 5 times 4 all the way down, and that's a big number.
Yeah.
So my favorite illustration does a tangent of the size of factorials, because it's really hard to fathom. Is I heard this thing I think is so great that if you shuffle a deck of cards, have you heard this before? You take any deck of cards, you shuffle it. You have just done something that has never been done in history. Is that you ordered those cards in that order. And that you can say with almost a 100% statistical accuracy that those cards have never been in that exact order before. Because in order to calculate all the different orders that cards could be in, it is 52 factorial, or how many cards are in deck cards.
Exactly.
And so that number is so astronomically large that you would have to have, I forget exactly how it was described. You would have to have like something like 100, it was like 100 million people shuffling 1,000 decks of cards 1,000 times a second since the Big Bang to only now be repeating orders of cards.
It's awesome, isn't it?
It's a massively large number. So as a tangent, but
just
to give a scope of how big.
I haven't heard this particular illustration, but it's good. It's good.
You should use it in class. Just take a deck of cards, say I'm going to do something never before done.
It's good. Mic drop, leave.
But just to give an idea of the scope of factorial. So even just having 10 different items interacting, there are thousands of different ways that those items can interact.
So basically, what you can do then is use this evolutionary process that I just described first, that you can take the rule sets that are good and basically evolve game rules. So basically you keep the good rule sets, you throw away the bad rule sets, and sort of make copies of the good rule sets. The good rule sets can also have sex with each other. So basically, like this rule set A and rule set B, they have offspring little kids that, are put in here. So it's like this Darwinian evolutionary process.
They hybridize the rule sets.
Yeah, exactly. And you make random changes to them as well. And you just do this again and again and again, and eventually get a good rule set. The problem is, what's a good rule set? And this is a little bit like, this is like one of these trivial problems, like, what is good art,
Right.
So in some of my early experiments, I used this idea that comes from at least 3 different directions. One is developmental psychology, where like these pioneers in developmental psychology, like Vygotsky, Piaget, and so on, they observed that kids, when they grow up, they seek to do things that they can almost do, but not quite. They try to basically find the limits of their ability and push that. So I've recently been seeing my son, who's 14 months old, learning to get down and up from the couch, which is, it's like he's not good at it. He's getting better, but he was like very bad, and and he tried to do it just because he's not good at it, and because he just falls down, and like there I'm standing looking and picking him up when he's falling down. This is innate drive to sort of find the limits of your abilities and push them. The same observation comes from game design. There's Ralph Koster is this game designer who designed a bunch of multiplayer games and a bunch of other things. So he's a famous game designer, and he wrote this book back in 2005, A Theory of Fun for Game Design. It's a great book. It's well worth reading. It's very easy to read, where he basically argues that one of the main reasons, if not the main reasons, we actually play games is that provide a challenge so that we can learn to get better at them. And a well-designed game is a well-designed pedagogical sequence where you gradually get better. And then it goes into depth about a lot of these examples, like Super Mario Bros. World 1, Level 1 is this classic example. You start out with a couple of simple challenges, like, oh, what's happening? You have this one enemy coming towards you, and you need to do something. Oh, you can jump. Oh, you jump on it. Great. Then you learned one thing. And then there's this one block ahead of you. What can you do? Oh, you can jump on it from below. Oh, and you got something. You got a coin, And then as the level progresses, you get several like atomic challenges, and then combinations of these challenges. They say harder versions of the same challenges at the same time. Oh my God, I got this block. I got to jump over the gap, and our enemy's coming, and and you sort of get better at that. And good games are built that way. Any good games, this is like you have this tutorial aspect to it.
But the tutorial is not didactic. You learn through the action.
Yeah,
it's pedagogical,
exactly.
Right? Like you are learning as you're actually behaving in it.
Exactly. So remember when games came with manuals you had to read before you?
That was even before my time. My brothers would have all the game manuals, and I would be like, "What is this for?"
Yeah,
Just play
exactly.
it.
Exactly.
And they're like, "No, you don't understand. If you're playing like Oregon Trail, like you gotta know stuff to even know how to play it." Like
exactly. Whereas we become better at that. We become better at actually teaching you how to do things.
Right.
So basically, a well-designed game, and part of the challenge is a big part of the reason it's good is that you sort of there's a challenge that teaches you to play it as you play it. Now, then the third direction the same idea came from was that was from machine learning theory. So my postdoc advisor, Jürgen Schmidhuber, the famous researcher who this is a camera, right? The famous researcher and sometimes infamous. I bet he won't worry if I say that. He knows, basically. He's done a large amount of legitimately huge things in deep learning and invented a bunch of things. He's also, some people think that he claims credit for things that was not his, was not really his inventions. It's a complicated matter. Let's not go there. It gets complicated.
Sure.
But anyway, so one of the ideas that is unquestionably his is the idea about artificial curiosity, and the idea that how do you create a curious agent, like a curious AI. And the idea is that the curious AI will search for the environments or the problems where it predicts that it can make the best progress in learning it. This often means that it finds things that are at the limit of its ability.
Just like your son.
Yeah, just like my son. Or just like a player of a well-designed game, according to Coster. So these things come together, and I feel like this kind of general idea is like it's there's an amazing validation when basically the same idea comes from three so extremely different directions.
And they all sort of fuse at this zenith, where it's like this is the form. I mean, it's also just a good metaphor for life, right?
Yeah,
like
it is, right?
In life, I think we find the most fulfillment and achievement as we are constantly pushing ourselves to do things that are outside of our capabilities.
Yeah, exactly.
And as soon as people are stagnant and they're just doing the same thing over and over, that's when they start losing purpose and start losing a fulfillment.
And if you feel like everything is easy and you know what you're doing completely, I can recommend having kids.
Yeah. You're immediately thrust with just new challenges every day.
You're like, what the fuck is happening?
Yeah. Oh, that's so interesting.
Yeah. So anyway, so like, how does this relate to like creating, to automatically generating new games? Well, the idea here is that the idea was that I wanted to create games that were learnable, but the evolutionary process. So basically, a game where you start out bad and rapidly get better. But the evolutionary process requires you to test like thousands or tens of thousands of these rule sets. And we don't have enough humans to sort of try to play these games because humans are, from the point of view of a fitness function that sort of evaluates something, humans are slow, they're inconsistent, they're expensive, they're just like hard to get. And avoid humans. This is my message. Avoid humans.
In life also.
Yeah, they're slow, inconsistent, expensive, all this stuff, right? No, if I wanted to avoid humans, I would not have moved to New York City, I guess.
Yeah.
I like humans. Humans are good.
No, we need humans.
Yeah,
we need humans.
Totally for
not
humans.
too many. But
Yeah, with garlic.
like slugs.
But anyway, so So I created another process that tried to learn to play. It's another evolutionary process. So now we had this evolutionary process that evolved game rules, and to check every game rule set for how good it was, I would run another evolutionary process to train a neural network to try to learn to play the game.
Right, and now it's a flywheel.
Yeah.
It's creating games, and then the players it's creating players.
Yeah.
In a sense.
Yeah. And did I create any good games? No. It created games that were kind of playable.
And you played some of them.
Yeah. Because I'm a masochist.
and what were these, like, what did they kind of look like?
It's like games where you move, blue circles around and interact in weird ways with other circles. One of them was a little bit like golf, if I remember right. You basically had to push these things away somewhere. Yeah, anyways, we kept doing more versions of this. And there's another researcher, some of my favorite work here at around the same time, Cameron Brown. We were both kind of like pioneers of this whole sort of generating game rules. He generated board games, and he had it was an evolutionary process as well. And it's a complicated setup with a lot of weird parts to it, a lot of hand engineer stuff, and the part of it was like he put a lot of well-known games into this encoded in the same description language, like checkers, chess, hex, a lot of these well-known sort of simple combinatorial games, Go, Gomoku, and Shiny Chess, and then basically mutated and recombined the rules, and then tested how playable they were. And he had a couple of things in there, including one of his hand engineered criteria was that a good game should be hard to tell, or it should not be obvious who was winning until close to the end. Which you could test with various ways.
It's a good criteria.
Yeah. And Monopoly is one of these games that consistently fails this criterion. Monopoly, game designers love to hate Monopoly because it's so completely biased, and it is like a positive feedback loop in game theoretical terms. But it's sort of, but that's also the point.
Right. Yeah.
It's like the social context of the game is different. But
as I understand it, the creator of the game was trying to illustrate the absurdity of capitalism.
Yeah, and a particular kind of yeah, exactly.
And basically created this game where the rich continue to get richer and the poor people get nothing.
Yeah.
And that was the purpose of the game. So obviously it's going to violate some game theoretical rules.
Yeah, exactly. And it is like, but then it becomes so popular. Okay, the version we play is slightly different from the one that was invented first, but yeah.
It is funny that it became so popular.
Yeah. It has some good parts to it, like this part where you actually need to pay close attention to what the other players do, because you need to charge them money if on your territory, for example.
Right.
So that's the thing that basically keep you in the loop more. But yeah, it's and it's also hilarious that many people play Monopoly with very little kind of negotiation to it, which is kind of sad because negotiation is the best part of it.
Right.
Where you basically have auctions and stuff like this, and you need to buy and sell from each other. I once was playing Monopoly with various people in my family, including my grandmother, and then my friend, who back then we were students, but these days he's an investment banker, and he's always had that mindset. And he came over, and basically my grandmother was losing, but so she just left, like, okay, I don't need to play anymore. You take over. And my friend came in, and he just turned completely around and won the game.
With her hand?
Yeah.
Oh wow!
Yeah, so he's like, there's a lot of skill to it actually as well. But anyway, it's also a positive feedback loop.
Right.
Let's just rewind the tape here. So Cameron Brown's system designed a game called Ludi. No, that's the name of the system. He designed a game called Yavalath, and this game actually has been moderately popular. You can buy it in in a box set and so on. And I won't say he didn't make him rich or anything, but it really sort of works.
But it is playable.
It's playable.
People seem to enjoy it.
Yeah,
and
exactly.
It's available on the open market.
Yeah,
developed through.
Yeah, developed by an algorithm, developed by a system, which was developed by Cameron.
Wow.
Yeah,
so that's impressive.
It's cool. I also continue doing other things. And another approach I had was like, basically, let's say you have like good and bad game playing agents, and you want a game rule set to be such that it is playable by the good agents and not playable by the bad agents.
Right.
So that like the good agents always get better score than bad agents. And we did this using something we call the general video game AI sort of benchmark. We wrote this whole bloody big framework, not only me, but a whole sort of bunch of people. And one of these like outputs were like games that, I don't know if you know Sokoban. No, it's a game about pushing boxes. So like one of these like eternally good games that people keep making new versions of. We made a couple of variations, games that were like, there was no master stroke to them or anything, but they were actually playable and somewhat novel. So, but yeah, there's a lot more to do here. And I think, I feel like really going to do this now. We sort of
revitalize it.
Yeah, exactly. Reinvigorate this thing.
So can you put me on the paper? You have to cite me or something.
Sure, yeah, exactly.
Okay.
Yeah,
this is the moment.
Yeah, exactly. Gagnon sort of,
That is fascinating.
Yeah.
But I guess in general, the models where it's actually just undergoing like human evolution, those I guess are outside of the gamified versions, right? Like those virtual worlds of developing intelligence through that. That is interesting, and I'm curious. Do you spend more time on that now? Like trying to develop intelligence through those kind of like evolutionary models? Because that seems to be, maybe that answers a greater philosophical question than the gaming versions.
Yeah.
And yeah, I could see that being of more general interest. The idea that like, oh, you can develop intelligence through these same exact models.
Because my life, like since I started with this, like has been completely split between, are we doing this to make better games or experience games? Or are we doing this to sort of make better intelligence? And
I guess it's both.
Yeah, I guess it's both. I guess the sort of, and there are many people that think about both of these questions. But I guess what many people don't really get, or where they don't share my perspective, is maybe a better way of doing this, is that there is like this deep connection between game design and intelligence. Where, this thing I said that game design is like basically a way of searching and characterizing our minds, because we are game designers of finding new challenges
for the mind.
Yeah. And then if any game designers listen to this, watch this, like, thank you, you're doing my job for me.
Yes.
It's like
interesting.
Yeah.
And now, do you have any concerns about the capabilities of AI outside of this? I know a lot of people have sort of like rang alarm bells about, neural networks learning how to program and improve their own code and things like that. My sense from you is that you're not tremendously concerned.
When I was going here, I was like, my wife suggested this T-shirt, and
good suggestion.
Yeah, thanks. Yeah, yes, like, and I had another T-shirt which I picked up somewhere, and I love it. It's like, it has this like kind of weird yellow color, which doesn't actually suit me that well, but it's sort of. It said, what does it say? Eternally optimistic, and it's like this picture of like a mountain walking around with a big smile, or I don't know if it is a mountain or whatever it is.
I mean, you're tall. Some consider you a mountain.
The mountain.
Yeah.
The Game of Thrones mountain. No, but it's and I've always felt like, I'm optimistic. This is my kind of basic mode of seeing the world, Yeah, sometimes, like, I guess it's a deficiency. Sometimes when people catastrophize too much, I just don't get it. It's like, what do you even mean? It's like, so this is just like, okay, this question is not about me. The question is about, are there any actual real risks? Yeah, I mean, we're going through this. It's a big technological change right now. We're seeing the introduction of technology with pretty wide general applicability, and that is going to affect like almost everything. Like, the things we now call AI, it's kind of social defined what we call AI. But right now, as of 2023, July, we're talking about neural networks, in particular things such as transformers, diffusion models, generative adversarial networks, stuff like this, and reinforcement learning. The things we call AI will be used in like almost everywhere in one way or another. And it's going to change a lot of things. And of course, people are worried because what's going to happen to their jobs? And is the AI going to wake up and do weird shit?
Do you think those concerns are valid?
It is valid to worry about rapid technological change because things change and some jobs might be might just like maybe some jobs will disappear. Typically, historically, few jobs completely disappear. Some jobs there will be less demand for. Many jobs will change in content. What you do is different.
Sure.
Like, and I think it's good to just like keep up to date with these things and see how it's going to change things. Generative AI's capabilities to sort of produce convincing facsimiles of like voices and texts and images and so on. It's gonna we need to figure out new ways of like establishing what's true essentially, because we have like we have systems that can produce like any number of like convincing sounding lies and produce convincing looking images and soon voice and videos to sort of go with it. And we need to figure out how do we trust things and how do we trust like all these images and text that sort of float around. How do we avoid a collapse of meaning? I mean, I'm not worried about that. I mean, of course we will sort it out, but it might create a lot of turbulence in society. I mean, the introduction of the printing press is, I think, a pretty apt sort of, comparison, where suddenly so much like monopoly on truth was challenged.
Right. I mean, you see the Catholic Church sort of have a great schism. The Reformation occurs around the same time.
Yeah. And I mean, the 30 Years' War was no joke. It's like it was pretty brutal.
Right.
And let's try to avoid that. It's like.
And these things were catalyzed by the printing press.
Very much, very much. So that's the thing, and these things keep worrying me a little bit, and I don't know what the right. What the right answer is. It's like there's no simple answer. I think like widespread education about what's going on is really important, and I think I'm very much of the opinion that we need to make these models widely available to people, as widely as possible, and let people experiment with it and build new things. And I am very much against that. What some people say that we should keep like AI behind lock and key and sort of strictly control it. I think that is just like going to lead to an increased crisis of trust, basically. Like if you're a big corporation like OpenAI and you sort of you want like a monopoly on these things that can tell the truth. Yeah, obviously, I would also join a conspiracy theory here. Like it's like, I think that's bad. So what other things are there to be worried about? There's other worries about autonomous decision making. Yeah. It's up to us where we sort of, to what extent we put like sort of semi-autonomous AI systems in charge of things. One of the best movies of AI from all time is WarGames. From 1984.
Interesting. I haven't seen it.
Oh, you should. I'm
familiar with it, but I don't watch it.
It's like you should. It has like it's an amazing time capsule of 1980s American pop culture, and terrible hairstyles.
Yes,
but
I know about that.
Yeah, right. It's like, but it's also extremely believable kind of story about like how some aspects U.S. strategic command, whatever, puts this AI system in charge of launching the nukes, and then basically it gets convinced that it's like fighting a war, and basically they can't stop it. And well, the the ending is like it's actually very, very, very good. Some people may claim it's kind of saccharine, melodramatic, but it's actually algorithmically correct, and that's
really?
what's so good about it. The actual planning capacities of the AI plays like a key driving role in here. So it's like it's a very good and very true movie about AI. Watch it, but what it says, I mean, what we can learn about it is not that AI gets evil and takes over the world. It's more like, don't put it in control of the nukes. Problem solved. It's like, it's important we remember not to automate away ourselves because it's a choice we make. I mean, we get like amazing new powers, and we can choose what to do with them, and that's up to us. Like, it's up to us and democratically elected governments and so on. And it's the same thing with like, would you want to have AI systems in charge of like all your credit approvals? No, you probably don't want it. You want their input, but you probably don't want them to be the only ones. And you want to design social and legal systems around it that put the onus on the right people, that make the right incentives and so on.
Could we create an AI to discern which things should be controlled by AI?
No.
We can't.
No.
Because then that is where the debate lies. Because I think most people agree, like, yes, AI should control some things, but not all things.
Yeah, exactly.
But how do we discern what those things are?
Yeah.
Because a mistake on that is a big problem.
Yeah, and how do we design like the right kind of responsibility and who is more responsible for what? Self-driving cars, big thing. Like, there's so many ways this could go. It's clear that we are on a path that we're getting increasingly better at self-driving cars. This was a lot slower than we thought it would be, but eventually they'll get good enough for very many cases. How many cases and where? And then we could do different things. We could automate it the way we could let people drive around with full self-driving, and we could give put the responsibility on these people that are in the driving seat, or on the car manufacturers, or on the people that make the software, or you could basically redesign cities to have like streets where people are not allowed and only self-driving cars allowed to sort of minimize risks and so on. So there's a lot of design problems we have.
Yeah, I think that's actually not a bad solution. Like, I could imagine a highway where humans can't drive on it. But a self-driving car can go 180 miles an hour,
right? Because
there's no unpredictability, because they all are under the same network and they all know what each other are doing.
Yeah, and highways are the simplest. I mean, they're the simplest case anyway. So it's like, but then what happens inside the city and who? Yeah,
right.
Yeah, this is so. Yeah, what I'm worried about. I'm not super worried. It's not in my nature to be worried. But yeah, there's a lot of like design problems for society, basically, and designing responsibility and stuff like this.
Right. I guess it's similar almost to the NPC problem that you have in video games.
Yeah.
Where society was designed without artificial intelligence.
Yeah.
So to inject artificial intelligence into society, we have a society that's not made for it.
Yeah.
And same thing with these video games. I know you've mentioned, it's like video games are built to have NPCs that are not intelligent.
Yeah.
So in order to have an intelligent NPC, you have to change the video game.
Yeah.
The format has to be completely different. It can't just be Zelda with intelligence. It has to be a different format altogether.
Yeah.
And I guess that is analogous to society.
True. Except we don't want to be, I mean, with video games, I'm all for like designing completely new genres of video games. I'm totally for that, because these are video games, and if it fails, then just have a bad video game. But society, like historically, people who like say that we're gonna redesign society from the ground up, it tends to be with less than good outcomes.
Right. Yeah. A complete redesign of society.
It's just like Pol Pot,
You're right. Yeah. Exactly. Because society has evolved this way naturally.
Yeah.
So maybe it is sort of a natural integration of artificial intelligence and have it evolve to integrate it.
Yeah.
Maybe that's the most effective way.
Yeah.
The intentional redesigning.
Things on top of it. Yeah.
Yeah. The intentional redesign is probably going to cause some problems.
Yeah. It's just like we sort of keep tweaking society, but it's like it's. I don't want this kind of like we're gonna build. I mean, sometimes you see these kind of like libertarian crypto people like we're gonna buy some island outside Ecuador or whatever, and there we're gonna have like our we decided from the ground up in different rules, which is like, it's fine as long as like, you know, that only concerns like these people who move there, and then
0.5% of consenting people don't want to be there.
Right, exactly. And then there's a ticket out when it gets too crazy.
Right, exactly. It's a good experiment, but there has to be a fallback.
Yeah, exactly.
Right.
So,
now, as far as like the alignment problem, are you pretty confident that as AI develops, it will keep humans' best interest in mind?
These are tools. They do what we tell them to. Yes, they get very much complicated. They can do things that the sort of the outcomes of our instructions can be very complicated and so on and unforeseen. That's kind of like the thing. I don't think there's an alignment problem. It's like saying that there is a doing good problem, basically. There's just like a lot of like specific technical and societal technical questions about how to make systems more controllable and more transparent, and societal questions about like how to build responsibility and institutions on top of them and so on. So the whole thing about like, you know, in fact, this kind of common framing of the alignment problem, which is like Isaac Asimov's like 3 laws, like this is, you know, you put in some kind of like constitution of like, this is the basic things that you must respect. I find that slightly fascist in the sense that, you know, who are you to decide that these are the inviolable rules? It's like, it was never a good idea sort of to sort of put in like, inviolable rules are something that you should be very careful with in general.
Right.
And it's something that has tended to grow organically in societies. Sure, it's good. Like, United States has a constitution. It's mostly pretty good. You can quibble about some parts, but most of it is like, makes sense, you know?
Right.
But the actual application of this is like something that goes through courts at different levels and a lot of argumentation, a lot of like, you know, there's no hard and fast rules. It's not like a game where like, you know, you can't break the rule because that's in code here.
Right.
And I think that's how it should be, more like, you know. So I'm skeptical. I'm not saying I'm totally against this thing, but I'm skeptical about like attempts to make these are the inviolable rules that all AI must follow.
But the idea that, innocent human life shouldn't be killed.
Yeah. But it's like, you know, if you read Asimov's stories, a lot of the plots in many of these stories are driven by like the absurdities that result from like these rules being in conflict with each other, or like being applied in ways that they shouldn't, or being circumvented without breaking the spirit but not the letter of the rule.
Right.
So it's like
there's always ways around. There's always ways to sort of to lawyer your way around these constitutional rules.
Yeah.
That's interesting. So you're a little on the fence about just injecting just full stop binaries to control these intelligences.
I would say, by default against it. It's a contextual thing. You have to look at what is this particular AI system meant to do, and what is it, what is it used for, and then what's the safeguards, who's responsible for what it does, and stuff like this. And then, of course, like, you know, something I'm very much against for is this idea of like is the idea of like, let's build this one big system to have everything that controls everything. That is actually dangerous. Like, you know, successful societies have this very widespread division of powers, not just like, you know, executive, legislative, and judicial branches, but like, you know, this huge civil service, and then on top of that, like all these private companies, and, you know, you have lots of centers of power that keep check on each other, and like historically in society where like you actually have this one centralizing thing that controls everything, it's like it's not a good thing. Things tend to go bad.
So this idea of a one world government controlled by a singular AI system.
It sounds like something straight out of dystopian stuff. Yeah, it's yeah. Please, thanks, but no thanks.
Right. Yeah, that's interesting. And I think a misconception a lot of people have with the dangers of AI. I've talked to some people, just friends of mine, about what they're concerned with, and it seems like people have an idea that all AI is all connected.
Yeah.
And can you like speak to that? Like people are like, oh, well, ChatGPT can, it can think, and all these other things are thinking, and they can create this big web of intelligence that'll just destroy us.
Yeah, no.
Not realistic.
I mean, have you seen any other living being like that?
Right, human beings are not that way.
No. I mean, which is like we're just amazingly good at disagreeing with each other, and this is what makes life interesting. And like trying to synchronize, like trying to control like a lot of like the decentralized system is just very hard, and extremely often like it just doesn't work that way. Attempts at central planning in various societies have typically gone very bad, even if it's something as like seemingly innocuous as like iron ore production. It's like, yeah, no, sorry, it's like centralized planning is very questionable at best.
Yeah.
And cultural revolution at worst. It's you sort of in this idea that an AI system would just like basically somehow control everything. How would it work? Where is that system? But it's like, no, it's like there's no technical feasibility about it. But then someone would say like, but what if it could? But that's something that's now we're sort of coming up with arguments from like thin air and magic, basically. Right. You can say that about anything. What if there's a mind control virus that lands on Earth tomorrow and turns it all into zombie slaves?
Well, it doesn't exist.
Yeah,
but what if it could?
Like, what if it did?
Yeah,
that would be bad. Yeah. How are we gonna prevent that? I don't know. If there's a flying saucer, shoot it down.
Yeah, right. That makes sense. Yeah. So this idea that all these things can sort of just autonomously sort of unionize against human beings is pretty rare.
Yeah,
that'd be pretty difficult.
I mean, it's just like I don't see it at all. How it would happen, why it would happen. What would be the mechanism? What would be the reason? What would be anything? It's like
right. What about like autonomous, like intelligent robots?
Yeah,
something that exists in a physical world, which I know you hate the physical manifestation of artificial intelligence. But
disgusting.
Conceivably, I could see a military being like, all right, we're going to come up with AI police that will have guns and they will patrol the people.
Yeah. I mean,
and that seems a little bit more feasible, and it would be controlled and do the bidding of the government.
Yeah, so that's again the thing. That's is like what I think is where I see the potential danger is not in that AI decides to take over everything, but that someone decides to build centralized systems that control too many things, and then outlaws all competition. So. Am I implicitly comparing OpenAI to authoritarian dictatorships? Yes. I am actually really. There is there's like this kind of stream of. There's this field of AI safety, which I am very skeptical about, and some people in that field just like seem to have a very low opinion about humans and humans' ways of forming societies, and tend to be like, oh, we should protect them from themselves by building these like sort of centralized systems that and I strongly disagree with that. I don't think AI is the danger. I think they are the danger.
The human beings.
No. These particular people who claim to be concerned about AI safety, but but whose recommendations are like sort of all about control and centralization and sort of avoiding spreading AI to the people, essentially.
And so you're saying that there are specific individuals that are high up within these organizations that have a lot of influence, and that if they get the opportunity, they could centralize all of the intelligence force.
They're trying to drive policy towards that. We need to register AI system. We need to limit what can be released and so on. And
inevitably, that could lead to some type of fascist government type system.
Basically. And I mean, that's why, I mean, yesterday we had Meta released Llama 2 and a set of new, very powerful large language models that are publicly available and everyone can use, and I think it's great.
Right.
And I saw that, and I know people who are on the AI safety front who would be like, you know, that will be in agony over this, and I was just like, yeah, fuck you.
So is OpenAI? I mean, the name of it sounds very open.
Yeah, they're not open at all. It's just like the biggest irony of it all. It's just ridiculous, and it's like a non-profit that controls a limited profit organization. Is the most hypocritical thing imaginable. I think they should just like the ethical thing to do if you're OpenAI would be to just dissolve and cease existing.
Really?
Yeah.
Why?
I think the policy choices they're making and they're legitimizing are just bad for society. Like the secrecy and the sort of the secrecy where they don't release anything about their models. They don't release the models. They don't release the algorithms. They don't release even like high-level descriptive information about the models. We have to wait until someone leaks it, like, you know, and the rumors come out, which is like what kind of good is that supposed to do to humanity?
That's the real danger.
Yeah.
And so
I mean, they are the problem. AI is not a problem. They are the problem. And OpenAI is the worst of them.
Really?
Yeah.
And what is their motivation, you think? Is it control? Is it money?
I think like all these kind of people who history and the world is full of people who come with the best and the purest of intentions, and when they actually get power, they don't want to give up power. They want to build in power, and they want to sort of, you know, continue to develop what they're doing, and sort of see their vision to fruition. And then in the end, they end up like, you know, destroying countries and starting wars and whatever.
Absolute power corrupts, absolutely.
Oh yeah, exactly. And then OpenAI just have way too much power. They should just be open source what they have and cease existing. That would be the thing. And they're a non-profit, so they should be fine with it, shouldn't they? They even sort of, you know, but no, you sort of, it's very hard to give up power.
Is there any concern that if they open it up, that other countries or other governments could get access to this and use it against us?
They already have access to, like, Llama, for example. Anyone can download it from a web page. GPT-4 is somewhat more advanced, but it's just like it's still another language model. And it's not like, you know, anyone can get access to this. The reason that the US is leading AI development is that we have the ecosystem around it, we have the organizations, and we have the financial terms where, like, talented people can get paid a lot of money.
Wow.
And there's also and there's also the openness. There's the ethics of people who want to work for, like, in an open, free ecosystem where they can talk freely about what they do and not be controlled by a government. So that's why we're leading the pack here, basically.
Mm-hmm. I mean, that's just a fascinating idea. It's not artificial intelligence won't destroy humanity. It's the people that control it that will.
Yeah, totally. That's like, I don't think anyone will destroy humanity, but if someone did, that would be them, basically. Like,
wow.
Yeah.
That's a great nuanced delineation. I think that's important.
Yeah, and that's why it's like my prescription is like, educate as many people as possible, make models available to people, and let people play with things and come up with things. And the best defense against, like, you know, I don't subscribe to the view that the best defense against a bad person with a gun is the good person with a gun. I don't subscribe to it because it's not true, but because there's a good reason. Guns are like single-use things, you know, you can only use them for, like, violence or threatening violence, and which is why I think we should probably have sort of meaningful gun regulation, or not probably. I think we should have. But when it comes to AI, it's such a general purpose technology. So if you're worried about like a bad person with AI technology, well, you should have lots of good people with AI technology.
Right.
And this is the cybersecurity ethos, right? You sort of there is no such thing as like completely secure system ever, and there never will be. You have attacks and you have defenses, and you need a plurality of defenses to sort of defend against attacks that happen in many different systems.
Right.
So the best way of safeguarding the world is like spread knowledge about AI widely.
Let everyone have access to it, and let everyone have access to the information and the intelligence behind it.
That's my take on it. Yeah.
And I'm curious, to get off the negative, what are the positive aspects that you've seen artificial intelligence be used in society broadly that have like really excited you, or that you've seen that you were surprised by the application? Has there been anything?
Beyond video games, there are other things in society. Man.
Well, what else matters, right?
I think, as someone whose main day job is in a university, I'm a university professor and a startup founder, basically. I think education is like one of these really big things, because access to knowledge in a way hasn't been restricted for a long time, because we've had books in Gutenberg, and books used to be expensive, but these days, like in the vast majority of the world, you can get books for money you can afford about topics that you sort of want to learn from. And now we have instructional videos and so on. But we don't on YouTube you can find all kinds of things, and you still don't really have the same quality of education everywhere, because teachers is a scarce commodity.
Mm-hmm.
And I think that AI for education is a huge thing. If we do this right, we can really sort of multiply, and we can our efforts, and sort of we can make sort of quality education available to so many different people. I'm not saying that we're talking about people learning from AI only, but that is like a very powerful enabling part in this, especially this kind of interactive mode that chat-based large language models, or chat-enabled large language models enables. Is super useful.
The perfect teacher, accommodated to your learning deficiencies, the things that you struggle with in school.
Yeah, to some extent, and they can answer your particular questions. And I'm absolutely not saying right now that we're going to make all teachers unemployed.
They will work in conjunction, I'm sure.
Exactly. And I think this is a huge thing. We're going to see quality education available for so many more people.
Mm-hmm.
And we have I'm saying we do this right, because as I said before, we have an issue with truthfulness of large language models, and it's a fundamental issue. It's not clear that we can overcome it completely, and this is one of the many reasons we'll still need other human teachers to sort of help out with things. And also, like if we handle this the best, we can basically teach people that critical thinking, like this is what the language model said. Does this make sense? You need to check this. You check the sources, And
could you send a language model through an evolutionary, like prototypical system to create and like selecting for truthfulness to evolve a more truthful language model?
Maybe. The big issue is selecting for truthfulness in the right way and designing this fitness function. It will be great. Definitely something to work on. I know people are working on different ways of measuring truthfulness and so on. And this is definitely one approach you could take to sort of try to improve it.
Mm-hmm. That seems to me like if there's a way that you could select for truthfulness and have a human vet the efficacy of or I guess the legitimacy of the truthfulness on a scale perhaps, where it's partially true, it's like almost like Snopes or something, to then select and sort of train it in that way through human reinforcement.
This is this is what's sort of really, this is what's so exciting about AI research. I don't know. Maybe we can do it, maybe not. It's like empirical stuff.
I'll help you out with it.
Yeah, it's good. You need to. I've been lying all this time, So it's like,
do you work in NYU? Do you know anything about this? Have you been making all this up?
Live around here, and sort of work in a coffee shop.
A couple of the last things I want to ask, just related to like the really exciting implementations of it.
Yeah.
I mean, one is video games, obviously, that we've talked about, not only in developing video games, but just the idea that you could play a video game that is perfectly customizable to the things that you like and the way that you enjoy playing the game, and making it exactly as hard as it needs to be for you, and that it could effectively be perfectly malleable, and that your experience with the game would be perfectly unique to what your temperament is as a human being. That would be cool.
I agree. That's like something I'd really, really love to do. It's funny, I've been saying this kind of thing for like, in different guises for like at least 10 years or more. 15 maybe, I don't know. And I've been going around and saying this, and then I went and I would say it to like researchers who were like, this sounds interesting, but it sounds hard. And I would say to people from the game industry, it's like, that's never going to work, and also we don't want it because we're designers and we want to do things the right way. Also, AI sucks. Recently, I saw this article and Twitter thread from someone at Andreessen Horowitz, the huge venture capital firm, where they were basically arguing exactly this, and I was just like, huh. And it is some kind of indication, right? People used to say that it's not going to work, and also it's not good, and we don't want it. And now it's just like, actually, we want to throw lots of money at people who want to do this.
Yeah, like, where were you 15 years ago?
Yeah, exactly.
But that would be so cool. I mean, I've heard this idea with film. You could watch a movie that is sort of, algorithmically keyed in to the things that you enjoy. Yeah. And you could watch a movie that's perfect for you.
Yeah.
And
I mean, not everybody want it. Not everybody want to do that. At the same time, with games, there's going to be games, especially esports like games, where like the whole thing is like fair competition. Right. You're not going to see that. And there are games that are very much like more focused on like the sensibilities of individual indie creators. But this is one type of new interactive experience that we could create. That would be lovely, and I would love to do that. But Jesus, there's so many things to do.
Yeah, I know. So little time. So many games to play.
Yeah. Oh, yeah.
Are there future iterations of intelligence or artificial intelligence that'll be coming to the general, consumer in any anytime soon, that people might not be aware of, that you being on the forefront might be aware of?
I mean, the same thing that happened with image generation is going to happen with video generation. It's just like a few years behind. Mm-hmm. We're going to have this conversation in 2026 or whatever, and people are like, we're going to have short videos that are almost indistinguishable and like from other things, and people are going to be, oh my God, the what is even true anymore? And yeah, that's one thing. That's kind of low hanging. A lot of AI, like real sort of, impactful AI, you don't really see it. It's the same thing as like, these companies that do stuff that we all indirectly depend on every day, that you rarely see, and like enormous transformers and stuff like this. Well, transformers in neural network, but it's also transformers that create electricity and transform powers and stuff like this. So mining and resource extraction is another field where we're super limited by lack of information and lack of modeling this information and so on. And I advised a student of mine who started a startup that does Origin.ai, that does basically it helps with oil extraction and gas extraction, and also the reverse of that, which is basically sequestration of CO2 and so on into the ground, by actually modeling and simulating underground reservoirs, because we know very little about that. It's like one of these fundamental problems. How do we know what an oil field looks like, or how do we know the shape of a cavern we could pump CO2 in from, to save the planet? We don't really, because we set up basically a few explosives up at the ground, and then we listen to the echoes, and we get these very rough pictures, and then we try to figure out our best guess of what this this geological shape looks like, and then we try to simulate it. And simulating it is extremely expensive. Then Ruben, my student, he came up with new ways based on neural networks. I had a little hand in this as well, basically to sort of use these neural networks to simulate what happened like 10,000 times faster. And suddenly you can actually optimize for this. Suddenly you can sort of do real-time planning because you can simulate something in a second that used to take a day. And that was like, in that it's going to downstream have huge impact on how we do resource extractions. Can be used in mining, for example, as well, which we need if we're going to sort of, affect this green revolution. We need all these rare metals for solar cells and for batteries. The problem is that we don't really know what's in the ground until we start digging and drilling. It's very expensive. If we can use AI to better model this, then we have huge efficiency savings, and we can make new things possible.
Right.
So this is like one of these things that you don't notice it in your everyday life, except in a very indirect fashion.
Mm-hmm. Right. I mean, both financially, environmentally, and then geopolitically as well.
Yeah.
Right. Yeah, like, would it stop conflict if people are fighting over disputed land that they realize doesn't have the resources that they want?
Yeah.
Could people be like, all right.
You could start new conflicts.
Yeah, we'll do conflicts somewhere else.
That's the problem. People will have conflicts, It's like...
Right. Yeah. Fascinating.
Yeah.
I mean, Julian, this has been so great. I appreciate you for answering all my questions. This is
a great discussion.
Yeah, I really enjoyed it a lot.
Me too.
I follow you on Twitter, which is how I actually got in touch with you and found you in the first place.
Yeah.
You have excellent Twitter feed, and I really love reading the things that you post and share on there. So continue sharing, please. I'd like to read about it. Yeah. And yeah, if you have do you have anything that you want to plug or any specific things that you want people to check out?
I do. I mean, there's going to be a book in this MIT Press Essential Knowledge Series. We have a book on artificial general intelligence. It's going to be out sometime next year. So not there yet. It's supposed to be like a book for the general audience about this whole concept of artificial general intelligence.
Oh, that's great.
I just have a first draft of it. It's finished and it's out for review. And, I'm going to, sometime this fall, we're going to have a final version of it. And then the whole sort of, editorial thing.
Well, if I can help in any way, I'd love to read it just as a general person that's interested. Maybe I could offer some feedback. Maybe I'll find some typos or something.
Yeah. Like, this is so wrong.
Well, thank you so much, brother. I really appreciate it. And I look forward to talking with you again.